pressing the wrong button part, guys.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, welcome back to the channel that does to stupidity what Omni-Man did to the Flax and the Homeworld. If you haven't seen Invincible, go and watch it, because Season 2's nearly out. So thank you if you are here for the second debate of the night. Dave, from just now, will be back on Friday, hopefully with a working microphone and not the tin cannon string that he appeared to have tonight. But we're going to have a decent discussion tonight with someone who I've actually spoken to before, alongside MC Toon. It is Wendell. Wendell, hello, welcome to the channel. How you doing?
Hey, what's up, guys? How y'all doing today?
I'm not doing bad at all. So we have had a discussion before. I apologise for not recognising you until you were actually in the call.
It's all good. It's all good, dude.
But for the people that haven't seen you, why don't you take a couple of minutes, introduce yourself, and let us know briefly why you think the Earth is flat.
Well, I'm Wendell Varner, and I typically think the Earth is flat because, first of all, there's a lot of things that can be said that's true on both sides. So whether the Earth is flat or round, a lot of arguments can go either way. For me, both ideas are probable, but the idea that the Earth is flat is more possible. I mean, let me say that again. Both ideas are possible, but it's more probable that the Earth is flat, from my opinion. I've seen laser tests that shot lasers over, 20 miles, and people were still able to see the laser, which proves there was no curvature. We can't really detect the motion of the Earth. And like I said, there's just a lot of reasons why I think that the Earth is flat. And I think I can break it down scientifically.
Okay, awesome. So why don't you just give us what you'd say is maybe your two best bits of evidence for the Earth being flat, and we just start the discussion from there. No real format, but if you just take a few minutes and give us your best bits, and we'll go from there.
Like I said, for me, it'd be more of a technical argument. So it's not an argument that we could just, it's going to take a little bit of technicality to it. So for me, first of all, I like to start with the standard model of particle physics. And the standard model of particle physics, gravity can be omitted. So there's typically two types of thinkers out there. There's the Newtonian type of thinker, and then there's the lines of a general relativity kind of thinker, even though I don't agree with everything for relativity. But I do understand that mass does not attract mass, and that gravity can be omitted from the standard model of particle physics, which means that it's not a true force. So in general relativity, is a pseudo force. It's a fake electromagnetic force. And I think anybody with any kind of physics background can typically agree with what I just said. So for me personally, gravity is defined as the geometry of space. What does that mean? That means that gravity is the shape of space. It gives us our cardinal directions. It gives us our downward direction. All right. So for me, when the Big Bang occurred, if the Big Bang occurred, using your logic, these three forces were once one force. The shape that can that contain these forces is what I would call gravity. And from that point, we had a down direction, we had an up direction. Everything that the human does is going to be relative to that up and down direction. Now, I understand that you guys think in space that there is no cardinal directions, but from what I can say, I can debate otherwise, and I don't think that you can prove any different. Like I said, mass doesn't attract mass. We see that with the light gravitational lensing. So if that star was not displaced, then we could say that gravity did not affect light. But since gravity affects light, we know that a photon has no mass. There's a relationship between energy and mass, but that photon itself has no attraction. Due to gravity. So what gravity is actually the curvature of space. And I think a lot of globies don't really understand that. The reason why things accelerate towards the Earth at 9.8 meters per second is because for some weird reason, we can cancel out the gravitational mass versus the inertial mass. And I can't for the life of me understand why you would be able to do that if they're not, generally the same thing. Now, conceptually, they're different. And I'm pretty sure you're smart enough to know the difference between gravitational mass and inertial mass. But once we cancel those two things out, everything is essentially weightless. It has no mass. So if everything has no mass, it's going to accelerate at the same rate. Everything is the same at that point in time. And that's why things accelerate down at 9.8 meters per second. Now, the Earth is stopping you from your natural acceleration downward. We will be naturally accelerating. Well, we would be pretty much considered at rest. In general relativity, we would be considered at rest. And the Earth would be moving up towards us and creating a force against us, which we know, like I said, that's a fictitious force. And I can describe this fictitious force of gravity using your globe. If we both stand on the equator 1,000 miles apart and we both walk towards the North Pole, we're going to gradually get closer to each other. There's no force pulling us to each other, but we're gradually getting closer to each other. And that's because we're walking a straight path through a curved space-time, which is, I think y'all call a geodesy. So, like I said, that's pretty much my biggest argument for the Earth being flat at this point. The equivalence principle tells us to focus on the experience of the observer. And from our observation, from human observation, the Earth is always going to be flat. Space-time is flat. And that's just how we're going to observe the Earth.
Okay.
As non-inertial observers. Now, if we were inertial observers, we might view the Earth differently. I get that. But in a non-inertial situation, we can only view the Earth as being stationary and flat. And I think that most of y'all would have to agree with that.
No, I would definitely disagree with the final assertion there. Okay, so there's a vague understanding of Einsteinian versus Newtonian physics, but there's also a lot of mixing them up there, which I think is some of where the issue is coming from. One thing that stood out in particular of what you said was about mass doesn't attract mass because we see a deviation of light by stars. Well, that doesn't work out. From the photon's point of view, it's still traveling in a straight line. It's just going through curved space.
Exactly.
Light isn't being attracted. But like you said, energy and mass have an equivalence. But from the photon's point of view, it's technically going, well, it is going in a straight line. And it's actually an excellent demonstration that gravity does what we say it does, as in it curves space-time to make things that are traveling in a straight line actually curve. But we'll get to that. I just want to address a few of the points you said quickly. Gravity in the standard model of particle physics. Yep, that's fine. Gravity doesn't need to be in the standard model of particle physics because particle physics deals with the subatomic world. And in the subatomic world, gravity is absurdly weak. Newton's law of universal gravitational attraction, Fg equals gm1 m2 over r squared, describes an attractive force that is proportional to the mass of two objects and inversely proportional to the distance of the square between them. And when you take that into the subatomic world, the the maths works out to practically zero. So that's why gravity is omitted in the standard model of particle physics, because the standard model of particle physics just deals with the subatomic world. It doesn't deal with the world on a macro scale. Gravity itself is an empirical fact that we need to take into account. What else did you say? You were talking a lot about the difference between Einsteinian and Newtonian gravity in the way it's described. That's all well and good, but we don't live in an Einsteinian world. We live in a Newtonian world. And that is the way that here on Earth, we should look at what gravity does. Because it is an empirical fact that mass appears to attract mass. And that was what I wanted to focus on, was your claim that mass doesn't attract mass. How do you quantify that claim in particular?
Well, first of all, we know that Newton was later on in history. He's more modern when we consider the idea of gravity and our downward acceleration and whatnot. So
yeah, he's the one that gave us the law, though, right?
Say that again?
He's the one that gave us the law of gravity, right?
Yeah, he's the one who gave us the gravitational constant, and it, developed later on into that gravitational constant. But what that did is create a mathematical construct in some sense, because we know that, first of all, mass does not change. So there's certain times that Newtonian constant doesn't have to be used.
Sorry, what do you mean mass doesn't change? What do you mean by that?
Mass always stays the same. So if your mass is X here, your mass is X on the moon.
That's not true. Sorry, your mass. Yeah, your mass is the same, but your weight is different.
That's what I'm saying. Exactly.
Yeah,
so that's my point.
Your mass is exactly the same, but your weight is different.
So if you listen at what I'm getting at, weight is a construct that was created in the 1800s. Before the 1800s, before the gravitational constant, the word weight and the word mass was used synonymously. They were the same thing. So, and they're measured in kilograms. So up until the 1800s, we did all of our measurements of weight and grams. All right. So if you weigh X grams here, you weigh X grams on the moon. All right.
Yeah.
And
there's a reason for that. They didn't have an understanding.
Say that again.
They didn't have the understanding, of what mass and weight actually were. Once it was, once we redefined scientifically what weight was, that became how we would calculate it. And we had to differentiate between weight and mass, because even though the mass of something does stay the same, even on Earth, the weight of that thing can change based on where it is on Earth.
How do you calculate mass?
Well, mass is, in kilograms, right? In grams.
How do you calculate? How do you calculate weight?
Weight is mass times the gravitational acceleration.
Exactly. So
that means that the weight of something would change if you go to the moon. But your mass is always going to stay the same. If you say that you are a solid body that doesn't lose bits, your mass will be the same wherever you are in the universe. But the forces applied to that mass are different based on the gravitational acceleration you're under. So if you're on Earth at the equator, you're going to have just under 9.8 meters per second squared. If you're on Earth acceleration, which means your weight's going to be something. But then if you go to the poles, your gravitational acceleration is slightly more, which means your weight at the poles is slightly more, even though your mass has stayed the same. And this is something that has been shown to be a problem in things like weighing gold. That gold has to be weighed on counterbalances rather than spring scales, because it will you have to differentiate between the mass and the weight. So if you went to the equator and bought some gold and then traveled north towards the poles, you could sell it off and make money, right? No, they have to calibrate scales where they are on Earth with a standard mass to make sure that it's the same, because where you are on Earth, when you change your latitude, your weight actually changes.
Well, you're going to have to calibrate your scales regardless. No matter what you're doing, you're going to have to calibrate your scales, even over time. Just from using scales, you're going to have to calibrate them. And in my mind, if you go to the moon, like I just asked you a question and said, if you weigh yourself in kilograms. All right. And if you go to the moon,
well, I weigh myself in
and
stone.
you weigh yourself, huh?
You know, I don't weigh myself in kilograms, you know, because your weight isn't measured in kilograms. That's a mass, you know. You would weigh yourself in like stone or something, pounds.
And what I'm telling you, what you're calling weight is a mathematical construct, because if you took a measurement of your mass here on Earth, if you stood on a scale and took a measurement of your mass here on Earth, and then you went to the moon and you took a measurement of your mass on the moon, your mass is not going to change. Your weight is not needed in Newton's laws.
But
of
okay,
motion.
so
all right,
the scale. If you take the scale to the moon, right? So let me just respond to that quickly. If you weigh yourself on Earth with a scale, so you stand on that scale on Earth, it's going to show, like for me, it's going to show like nearly 16 stone, right? But then I take that scale to the moon, that scale is going to show something else. That scale is going to show that I'm 1/6 of the weight. Whatever that scale measures in, even if that scale says it measures in kilograms, what that scale says will be different when I go to the moon and weigh it, because the force being applied to me is less because the gravitational acceleration is less. Your mass has physically stayed the same, but the scale that you weigh yourself with will say something different.
Trust me, I get exactly what you're saying. That's why I asked you the question. I said, how do we measure mass? So whatever method you're going to use to measure your mass, it's going to be the same when you get to the moon, because your mass will never change. And following Newton's law, even if we apply forces and acceleration, it's going to be the same as it is here on Earth, because your force equals mass times acceleration. It has nothing to do with your weight. Your force equals mass times acceleration.
Yeah,
it has nothing to do with your weight.
Weight is a force,
whatever
right?
Whatever method you use to calculate your mass, let's take weight out of the equation. Whatever method you use to calculate your mass will be the same here as it will on the moon. The forces that it takes to move you will be the same as it is on the moon. Force equals mass times acceleration.
Yeah, so but it won't be the same because the acceleration on the moon is different.
I mean, that's something that we
so the force
prove.
isn't going to be the same because, like you've just said, weight equals mass times gravitational acceleration. The gravitational acceleration on the moon is something like 3.6 meters per second squared, right? So your weight, the force you have will be less. So there will be less of a force acting on your mass.
I trust me, like I said, I get that. That's simple. And what I'm telling you is I don't agree, because I feel like, first of all, we can't ever get to the moon to say that, our idea of the weight of the moon is based upon a mathematical construct. It's based on the motions that we detected, how fast and how far we see these things move over time. And that's how we come up with a calculation for the weight of the moon. Just like how we come up with a calculation for the weight of the Earth.
But it's been empirically proven.
The weight of the Earth, say that again?
It's been empirically proven, though.
I mean, how? I mean,
we went to the moon like a bunch of times.
I mean, could you explain how? How can we
with big
prove
rockets
the weight of the moon?
By testing the calculations and seeing if they do what we say they do, and they absolutely do, as shown when we used the calculations to go to the moon, and they were right.
Well, see, and like I said, I'm one of those guys that don't believe we ever went to the moon.
I mean, whether you believe it is irrelevant. To be honest, Wendell, we went to the moon.
You're right. You're right. What I believe in is irrelevant. But when they show me a lot of false information, and trust me, we can have a whole show on that later. When they show us a bunch of false information about the moon landing and the things that they did, and then
but they don't show us false information.
Mysteriously disappeared. They did. The guy falling down and the guy trying to pick up the hammer. You could tell that guy was on a harness, man. I mean, that's common sense. And maybe we did go to the moon. I don't want to say, like you said, maybe we didn't go to the moon. But we don't even need to do the moon. Like I said, we can do it on Earth. It is a fact that on Earth, there is points where the gravitational acceleration is different, right? Your gravitational acceleration on Earth is different at the poles than it is to the equator.
Your mass doesn't change, but your weight physically does. The scale that you stand on will show different. You have more of a force acting on you when you are at the poles than you do at the equator.
So explain why, in general relativity, that force that you're claiming that's pushing down on you, that's going to be more at the poles than the equator, or less at the poles than the equator. How does general relativity explain that force of gravity? Because what I was taught was that force was a false force inside general relativity. That force can be
force isn't the right word. Pseudo force, not false force.
Well, you do realize that the word pseudo means false, right?
Not in the scientific context, no. A pseudo force is still something that exists, but only in a certain reference frame.
I mean, what does the word pseudo mean? It means force. I mean, we can debate that, but the word pseudo means force. Means
words are a liquid, but in the context of science, a pseudo force just means an inertial force. It means an emergent force, a force that happens because of something else happening that you can measure only in a certain reference frame. It doesn't mean that force isn't there, because, you know, if you get on one of those fairground rides that spin and stick you to the end, you can bloody feel a force pushing you. That's centrifugal force. But that's not a real force. It doesn't actually exist. It's a pseudo force, but it's still there. You can still measure it. It's still a thing that exists, but only in that particular reference frame. You know, the phrase pseudo force doesn't mean false in a scientific context. You can't just take words and go, oh, well, that has this meaning, so it must mean this. In science, words have specific meanings.
Right, and I do understand that. And a pseudo force in science is a fictitious force. So when we describe gravity or the Coriolis effect in general relativity, we describe them as fictitious forces. We describe them as pseudo forces. So to the normal person, like I said, I don't have a PhD. So when I read the word fictitious force, or when my teacher teaches me that it's a fictitious force, we understand that this force is not real.
Well, and then you didn't have a very good teacher then, because they should have explained what that actually means. And that's the thing. If you don't understand science and you see a word like fictitious force and you think, oh, it's not real, it's, you know, it's fake, it's not real. But that's not what it means in the context of science. You know, and your teacher should have explained that to you.
Well, they did explain it, and they explained it as this fictitious force is a consequence of the curvature of space-time. So when you're in free fall, you're actually going through a straight line path through space-time. There's no forces being exerted on you.
It's just a different way of explaining it.
So at that point, if at that point you are an inertial observer, you're going to see the people in front of you, everybody around you, accelerating upward at 9.8 meters per second.
Well, it would appear the same. That's Einstein's equivalence principle, isn't it? That it would appear the same.
Exactly.
You know, you wouldn't know. But the thing is, we don't need to think about general relativity, because the result of general relativity is the force that we can calculate. All right. And when you take like Einstein's 10 tensor equations for general relativity and gravity, you can break them down to Newton's law of universal gravitational attraction. And for us, we don't need to worry about general relativity. It doesn't matter. In our world, we can just measure this force that gravity creates. And it's an empirical fact that it exists. Why it exists, you know, the reason that Einstein explained, that's kind of irrelevant. It doesn't matter. What matters is that it's an empirical fact that there's a gravitational force between masses. This is something that can't be disputed.
So why can gravitational mass and inertial mass cancel each other out? Why are they initially the same thing, frames, even though they are two conceptually different things?
So, inertial mass and gravitational mass of an object are identical in value, but differ in how they're measured. That's it.
Right. They are two conceptually
that's it. They're the same
things,
thing, but you're just measuring it in a different way, right? But again, we don't need to look at that. All we need to do is look at a Newtonian world that we live in, because you know what? If you fire a ballistic projectile, you can use general relativity to calculate where it's going to fall based on the gravitational acceleration, etc. You can do that, but it's going to be really bloody hard and take a stupidly long time. You can just use Newton's laws, and it's a lot quicker and easier. All relativity is a more accurate and complicated way of explaining what we experience. Newton wasn't wrong with what he said. In a non-relativistic world, as long as you're not traveling near the speed of light or have stupidly high mass, then everything about Newton's laws work absolutely perfectly. And that's what we should focus on. Can we empirically verify Fg equals g m1 m2 over r squared? Can we do that? Yes or no?
We cannot. No, we cannot.
Then please explain the results of the Cavendish experiments.
Because it is based on a mathematical construct. It's based on some numbers that were created based on math, and it's something that cannot be that can't be verified. So we can never actually verify the distance of the sun to the Earth.
Well, we can use radar to do that. It's been done. You can use radar to verify the distance to the sun.
No, you cannot.
Yeah, you can. It was an experiment from 1969 where they actually did it. It's been done.
How could they do that?
With radar.
Dude, I mean, think about what you're saying. As bright as the sun is, you're telling me that they bounced the signal off of the sun and returned it.
Yeah, I've shown the scientific papers on this channel many times.
So let me ask you another question. Do you believe every single thing that they put out?
I don't believe anything. I mean,
these people have
belief. Right. Before we go down that road, belief is irrelevant. I don't have beliefs. I base my position on empirical facts and logic.
So just because somebody tells you that, hey, I shined a light to the sun, the brightest thing out here, and I got a signal back, and this is and we verify what Aristophanes said 2,000 years ago.
Yeah, that's been verified by doing the experiment lots more times with many more people. But there's also the fact that, we've literally sent probes to the sun. The Parker Solar Probe is kind of still within the star's corona, actually. So we know the distance to the sun is correct. But that doesn't change the fact that we can measure the gravitational attraction between masses here on Earth.
Well, if that's what you're saying, back to the
you do know what the Cavendish experiment is, right?
Of course, everybody knows what the Cavendish experiment is.
Right, so the Cavendish experiment is empirical evidence.
Cavendish did experiment in a shed using 4 steel balls. 348 pounds, I think, was the greatest size of the biggest ball. And with the Cavendish experiment, he said, the torque on that wire, that tension on that wire was so minuscule that, in my personal opinion, the forces that acted on those balls inside that shed could have been electromagnetic in nature. I don't know exactly what.
Let me respond to that. So the experiment has been repeated thousands and thousands and thousands of times. It's done by every single person in the world that gets a degree in physics. It's like the first year you do it. I know 2 people that have personally done it, built it from scratch and put it on YouTube. I did it myself when I was at university.
I've seen a couple of YouTubers.
Hold on. And it's been done with multiple different materials, in multiple different environments, getting exactly the same result, showing that electromagnetic could not be the reason for the result. The result is always the same, regardless of the design of the experiment, regardless of the materials used, and regardless of the environment it is in.
And regardless of the location?
Yeah.
So
BM Furble did it in a flat in Korea, and Blue Marble Science done his one in somewhere in mid USA, and now it's actually in a university as a display piece.
Right, but if what you're saying is true also, then the effects of that experiment should be affected by your location on the Earth as well, right?
Why should it be? No. Right, here's the thing. The design of the experiment is ingenious, okay? Because the entire experiment, right, has the same gravitational acceleration acting on it downwards. Right, the wire, the torsion bar, the masses, everything. It all has the same gravitational acceleration acting on it downwards. But what the experiment does is it measures the gravitational acceleration horizontally instead of vertically, because that means it cancels out the vertical because everything has that acting on. So you measure the horizontal acceleration to see if there's still an attractive force at, an acceleration in the horizontal fashion, and there is. Which means the location on Earth that you do it on, the position of the moon and the sun, it's all going to be irrelevant because all that stuff is going to be acting on the entire apparatus at the same time, and then you use the apparatus to measure a different acceleration.
Right. Like I said, for me, gravity is the curvature of space-time. So
that's one way to describe it.
That's
one way to describe it, but the result of the curvature of space-time...
So the result of your...
Yeah, the result of the curvature of space-time is an attractive force.
No, it ain't.
Well, it is, because we can measure it.
It's not a force at all.
Well, we can... but I'm talking about...
It's a consequence of space warping due to mass.
Yeah, and which means that we can measure an acceleration, right? We can measure an acceleration because of that, because space-time's warped, we can measure how much something moves towards the warp of space-time, and that's the acceleration we perceive, right? And if that thing has mass, right, that means that we can times the mass by acceleration and calculate a force.
How could that ball warp space-time when the space-time we are already in is warped by the planet Earth? Space-time is flat. So, I mean, we have to agree on that. Huh?
You can have multiple warpings of space-time. Like the Earth-Moon system is one gravitational well, right? But within that well, you've also got the gravitational well of Earth and the Moon individually. And even us sitting here, I've got my own gravitational well. But that doesn't mean that the Earth's gravitational well is gone. It's just that the Earth's gravitational well is much bigger. Every mass, all mass, warps space-time. Just how much? Because of how much the mass is. So, but the result of that mass warping space-time is that there's an acceleration between masses. And if there's an acceleration and there's a mass, there's a force that can be calculated.
Right. Like I said, man, I don't agree with that. And especially being the fact that, something simple that we know that mass is tied to the orbits and the gravitation of Earth and the attraction between the Earth and the Moon and whatnot. We also know that the Earth loses 90 tons of atmosphere every day. So that the mass of Earth should not be the same now as it was 2,000 years ago.
Yeah, but we also receive stuff from space, like comets and that. So, I mean, the mass of Earth hasn't really changed that much.
It wouldn't, and that's always, every time I give that argument to a globe earther, that's always they say, well, doesn't matter that much. Well, how about instead of making that assumption, let's do the math on it. We know that after 30 years, that's 1 megaton of atmosphere that we lost.
And compare that to the mass of Earth.
I don't think that we get 1 megaton of space debris coming back into the planet Earth to replace the the atmosphere that's lost, and that's every 30 years. So every 30 years, you're going.
I mean, we pass through an entire cloud of meteors every year, so I would disagree with you.
So
the Earth literally during hold on. The Earth during its orbit has to go through a cloud of meteors. It's why we get the meteor showers every day, the Perseid meteor showers, right? Because we are the Earth is moving through a cloud of meteors. So there's always stuff coming to Earth. Always.
We're losing 90 tons per day.
Yeah, and we're gaining a shitload of stuff every year as well.
But it has to be equal over a billion years or however long.
Well, it's roughly the same. There may have been a couple of. Hold on, Wendell. There may have been, a couple of percentage change in the mass of Earth since when it started to now. But overall, the amount that leaves and the amount that enters is roughly the same. But the amounts are so little compared to the Earth that it's barely relevant. You know, it's so small. But again, none of that changes the fact that we can measure a gravitational acceleration with an experiment like the Cavendish. And I just explained to you how it's definitely not electromagnetics. You can do it with different materials. And I'd like to try and focus on that. Why the Cavendish experiment does what it does every single time.
Like I said, there's some things with this globe Earth, flat Earth argument that I'll be the first one to say. I can't break it down. I've never personally done the Cavendish experiment. I do get exactly what you're saying. They negated the downward force so that they can measure the force of these balls moving towards each other, very minuscule. Hey, I don't know. I don't know what is the cause of the spinning of that in that Cavendish experiment. So I mean, I'm not going to tell you that I got every answer that you can throw at me as far as the flat Earth. I'll be the first one to tell you, dude, I don't know. You know, that's one that you probably got me stumped on for the moment. You know, like I said, for me personally, I'm going to have to look more into that and look at it mathematically for myself.
Well, like my friend Blue Marble Science, especially when he built his Cavendish experiment, you know, he recorded all the raw data and everything. You know, and I've got all that available. You could even rebuild it yourself. And actually, as I explained in my previous,
I mean, I looked at
debate,
that's too
one of
expensive,
the
cost
documentaries that I'm
that.
planning on doing is a documentary about gravity, where I'm going to be working with some of the engineering students at Edinburgh University to build my own Cavendish experiment inside a vacuum chamber. Inside a Faraday cage, which is inside a vacuum chamber, which means that you take away any atmospheric influence, and because it's in a Faraday cage, it takes away any electromagnetic interference.
Right. So is the original Cavendish in the Faraday cage?
No, I'm taking away variables that people complain about. I'm improving the experiment.
Exactly. That would be because that's what I was just complaining about. I mean, you know, if they had in a Faraday cage, then that would negate some of our arguments. Part of science is being able to scrutinize these experiments because, as we know, they develop and they grow throughout time. But you know, from a human perspective, from our perspective, everything that we view is flat. So, like I said, I just watched an experiment where a guy took a laser and shined it across a lake, and lined up perfectly. Now, I didn't scrutinize these guys. I don't know if they cheated on the experiment. I see the Pic de Finalis, that's 273 miles away. I see that image right there, but I also see, I also got another video that I'll show you that the light turned out straight. I see the Pic de Finalis or whatever that's
called. Here's the thing, though. Laser tests are not
273 miles away.
Okay, so
you know,
this is something that
miles away. So
okay, Wendell, this is something that people need to understand. Laser tests are not an effective way of measuring distances on Earth over long distances because
you guys got a fail-safe joker card called light refraction.
So well, no, hold on. Refraction is an empirical fact. That's something that actually happens.
That's your ace in the hole. If a guy is standing,
whether you say it's an ace in the hole or not, Wendell, the fact is that refraction exists and it's being quantified. So of course we're going to use it because it's a thing. It's something that cannot be denied that exists, right? And as lasers are light, they are subject to Snell's law and will refract.
They will refract. Of course, things will cause light to refract, but it's not going to refract straight to the target. So
why not?
Why would the refraction be perfect every single time?
Well, because they're aiming it at the target. They're aiming it at the target, which is also refracted.
Well, if that's the case, we're in another dualistic system where we can't tell whether it's flat or it's curved, because if it's curved, the light refraction is going to make it hit my target straight, and if it's
just
flat,
remove refraction
it's going to get the target straight. Huh?
You just remove refraction from the equation, or at least the majority of the refractive effects, by, you know, I don't know, going 200 meters above the surface of the Earth, where the refractive conditions are a lot less than directly over the water, where it's going to be the absolute most, which is what I
200
like to
meters
do.
above Earth, they're going to be in the free fall. So, I mean, if they're
No,
in the
not if you're just
ISS,
standing there. 200 meters, not 200 miles.
Oh, 200, yeah, I'm sorry, 200 meters, I'm sorry. Right. Well, like I said, that picture of that mountain that's 275 miles away, same difference. I mean, that thing should be hidden by 8,000 feet of curvature. If we use the Earth
If you
curvature
ignore
calculator-
refraction, yeah, of course, if you ignore refraction, that's the case. Which is
See,
why,
that's what
if
I'm
you
saying,
go up
no
200
matter what-
meters, if you go up for 200 meters and actually look out straight, right, then you've removed the majority of the refractive effects, and you get images like this, which are impossible if the Earth is flat.
Why is that image impossible?
Okay, simple, right? So we're 210 meters above the surface of the Earth. So we've removed a lot of the refractive effects that you get when you're directly at sea level over the surface of water, okay? So we are 210 meters above sea level. This comes from a video where he shows the surveying marker, and he's up a hill just round the corner from me, actually, in Fife, and he's 210 meters above the sea level, right? The bridges that you see are the Forth Road and Rail bridges. That middle pillar is the middle pillar of the new road bridge, and according to the engineering specifications of the bridge, that pillar, the tip of it, is exactly 210 meters above the surface of the Earth. Exactly the same as the camera, right? So we've got a camera and the tip of that bridge, which are exactly 210 meters above sea level. Now, those hills in the distance are about 45 miles east of Edinburgh, and particularly the one on the right is the one I'd like you to pay attention to, in between the two pillars on the right. That mountain is approximately 505 meters above sea level. 505 meters above sea level. However, it is falling down below a tangent of 210 meters above sea level. Perspective doesn't explain this because, as we know, perspective makes things appear to shrink into a horizon, never fall below or go above it. Train tracks don't, change, don't intersect. So perspective can't explain why something that is twice the height of something else, when you're looking at it straight, would appear below it. This image is impossible if the Earth is flat.
No, I disagree, dude. I mean, because the further that mountain is away, depending on your perspective, it is going to look like it's lower. The further that mountain gets away, the lower it's going to get.
Only
So
into the horizon line.
Like I said, we can...
It will never drop below the horizon line, right? So let's imagine, like, this is what flat earthers say to me all the time, right? That you're looking down a long hallway, okay? And the lights of the hallway, they appear to go down towards the center. And the floor of the hallway seems to rise up towards the center, okay? Those things that are above or below the center will never go the opposite side. So those lights, as you're looking down that hallway, will never go below the center of your field of view, your tangent line. They will shrink into it. And that's what we should expect to see in this picture. Those hills, if anything, should shrink into that red line. They should never go below it. That's not how perspective works.
The only reason that happens when you look at that hallway like that is because it's in that enclosed hallway. What you're looking at now is a wide open space. And like you say, you're up. So the higher up you get, the lower the background is going to be. You cannot.
But everything's in line.
Of Earth. Every sign. If you listen at Neil Tyson deGrasse, he will tell you you cannot detect the curvature of Earth from that height.
No, we're detecting the effects of the curvature of Earth.
You cannot detect the effects of the curvature of Earth from that height.
Yes, you can. You're doing it right now. This is literally detecting the effects of the curvature of Earth. This is not possible if the Earth is flat. Perspective will never make something fall below a tangent line. The same way it will not make things rise up above that tangent line. Perspective will make things go into it.
The higher you go.
But it doesn't matter how high you go when you're looking straight. Doesn't matter how high you go when you're looking straight. If you look straight, if you're 200 meters above the surface of the Earth and you're looking straight along, anything else that is 200 meters will be at that level. It won't appear to go down. It will appear to be at that level. Anything that is more than 200 meters will appear to go down to that 200 meters line. Anything that is less than 200 meters, as you look into the distance, will appear to rise up to that 200 meters line. Nothing that is above 200 meters will ever fall below that 200 meters if you have a tangent line of sight. Perspective says that will not happen.
Why does the horizon rise to eye level?
It does not.
It does. You can look at it. You can look out the window on airplanes.
Celestial navigation. The very fact that celestial navigation exists disagrees with the assumption that horizon rises to eye level, because you have to look down at the horizon and apply dip corrections to get your correct reading. We can. Well, I have one picture here. Right? This picture was taken by. Hold on. This picture was taken by MC Toon when he was in a plane. Eye level is marked. Mm-hmm. It shows what eye level is right in the center, and the moon is below eye level. The horizon does not rise to eye level. Even when you're just, I don't know, like a few meters above the surface of the Earth. Well, this is 5,600 feet. The horizon didn't rise to eye level. I've got a couple more images that demonstrate it. But yeah, so the horizon just simply doesn't rise to eye level.
The image that you're showing right now is perspective as well. All right, like I said, it's the angle.
Wait. So perspective stops the horizon rising to eye level. You're saying?
No, it depends on which angle you take that picture from. And
well, the angle is perfectly flat. You can see you've got the water level in front of you, showing that the camera is level. So horizon doesn't rise to eye level. Here is another shot from a plane, showing what eye level is. The horizon being extremely below the eye level. Here is Tommy Gronville. Showing the horizon below eye level. He's about 70 feet up. So, the horizon most definitely does not rise to eye level. Otherwise, we could never, ever, 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 ever have a picture of the moon below the eye level.
Well, I mean, you could have a picture of the moon below the eye level if the moon is not as high as you say it is and is moving on a straight line.
It still couldn't be below the horizon, could it?
It's not below the horizon at this point, is it?
Well, in this picture, it's below eye level, and you said eye level rises. The horizon rises to eye level. So if the horizon rises to eye level in this picture, the moon must be below the horizon.
Well, no. In that picture, the moon is then. Like I said, my statement is not totally accurate. The higher you go up, the more gap you're going to get between your eye level and the horizon.
So the horizon doesn't rise to eye level.
So listen at me. So listen at me. To me, looking at that picture, that's not too much different from me looking out my pier at the horizon over the beach water. That's not too much of a big difference. The difference that you see is how low the moon is in relative to the observer. The moon right now looks pretty low in the sky, relative
below the eye level,
to the observer. Yeah,
it's below eye level, which means that right. So as long as we can agree, Wendell, that the horizon doesn't rise to eye level.
No, but I mean that's pretty much what I'm saying. It's not going to be perfectly at eye level because, like I said,
because
that
it
picture
doesn't
that you
rise to
showed
eye
me
level.
just now, like that picture you showed me just now, that looks like the horizon is at the same point that if a person was looking out their window at the beach and looking at the horizon, it's going to seem a little bit below your eye level. What they're saying is that you're not looking down to see the horizon. So
yeah, you do look down to see the horizon.
Eye level, no, you're looking straight ahead and you're looking
at
the
horizon. Again, the use of a sextant
me,
disagrees with you. The fact that sextants exist and are used for celestial navigation shows that you absolutely do have to look down at the horizon.
You do not have to look down at the horizon. No, from
again,
observation.
Wendell, hold on. You can't just say that when celestial navigation exists. With celestial navigation, you use a sextant to look at the horizon, right? Then you have to apply a dip correction to bring your measurement down to the horizontal. Okay? Which means, by the very fact that you are doing that measurement, the horizon is, you're looking down at the horizon. Otherwise, you wouldn't need to apply that dip correction.
Right. Like I said, I never researched the sextant. So I'm
really
not going to sit here and
destroys the flat Earth.
Well, I'm not. I'm not going to sit here and debate you about a sextant right now because I've heard of them, but I've never debated. I've never researched them enough to debate you. So if we're going to debate sextants, yeah, you're going to eat me up. You're going to eat me. You're going to rip me a new one.
Well,
But
I'm
for
not
what we
necessarily
see,
debating
everything-
sextants. I'm saying the existence of sextants being used for celestial navigation
Ex-
disproves
exactly.
your notion.
And that's what I'm saying.
Hold on,
So if I-
it
so if I
disproves your
debate that
notion
fact-
that you are saying that you don't have to look down at the horizon. Sextants disprove that. You don't have to debate sextants with me, but the fact that sextants exist and you have to do a dip correction, it's part of celestial navigation, shows that you have to look down at the horizon, otherwise that part wouldn't be necessary.
So do airplanes have to do a dip correction as well?
You can use a sextant on board an airplane.
But that's not my question. Do they have to use dip corrections? Can an airplane take off and fly
An airplane
straight
isn't a
and go
measurement
straight-
device.
and go straight into outer space?
Well, no, because the atmosphere wouldn't allow that. An airplane uses the density of the atmosphere to maintain its altitude. So even if the Earth is curved, which it is, once an airplane reaches its altitude and balances the forces of thrust, drag, lift, and gravity and stuff, as long as you keep
It's gonna continue
those
going
forces
straight.
equal, it's just going to follow the curve of the Earth.
So it's just going to continue straight. It's going to continue.
No, it's going to follow the curve of the Earth.
So it's going to continue because the curve of the Earth is a geodesic, right? So that airplane would be flying a straight line path through curved space-time, through the curvature of
Oh yeah,
Earth.
we really don't
Am I
need to talk
correct?
about space-time when we're talking about airplanes. We can just talk about the fact that an airplane uses the
Well, when we-
atmosphere,
well,
which
when
is
we talk
also
about the
circular
curvature
around
of
the
Earth,
Earth.
Well, when we talk about the curvature of Earth, we got to talk about space-time.
Not really, no.
if this
It's
plane
irrelevant to measuring the curvature of the Earth.
Well, if this airplane is flying a straight line path and he's not flying and it's not a curved path, if he's not
The airplane
manually
isn't flying a
dipping his
straight
foot-
line path. The airplane is flying over a curved Earth.
But I
It's flying a
disagree.
curve.
The airplane is flying a straight path because if it wasn't, if it was flying a curve,
Well,
then
okay,
the
have you ever
airplane
heard of
would
the
have
Haversine
to-
formula?
Never heard of the Haversine formula.
So the Haversine formula is a special form of the law of Haversines, which is for calculating angles with spherical triangles. And the Haversine formula is something pilots use to calculate their distances between A and B. And it involves using the radius of the Earth because the Haversine formula is what is used to calculate the distance in great circle routes, which requires the Earth to be curved and have a radius. So the fact that pilots use the Haversine formula to plan their routes shows that they're not flying a straight path. They are flying over a curved Earth.
They can use different methods to plot their coordinates and fly over a flat plane as well. Like I said, I debated that same subject with MC Toon. And as smart as you guys are, it should be simple to imagine. Or if you plot these courses right, whether the Earth is flat or curved, you can use any method because the
disagree with that.
size of the plane, listen at me, the size of the plane relative to the size of your globe Earth wouldn't make a difference regardless. Just like I explained to MC Toon, it would be no different from me making a straight road map from one side of the United States to the other side of the United States. I do not have to represent a curve when I do that.
Okay,
I
but
can
to
make
calculate
one
the
flat map.
distances between 2 points on Earth, you have to use the Haversine formula. Planes don't just fly little distances. They can fly half of the bloody globe in one sitting, right? And to calculate the
Right.
distances between point A and point B, they literally have to plug in the radius of the Earth to do that. They have to use the Haversine formula. Their flight
When was the
planning.
Haversine and floating invented?
Sorry?
When was the Haversine formula invented?
Well, the law of Haversines
Like I
has been
said, I'm
around
sorry.
since,
Yeah.
the time of ancient Greeks who did spherical trigonometry.
I got you. No, I was just asking. I don't know anything about the Haversine
Yeah.
formula.
But the Haversine formula,
like I said, if
you
I
need to
was
speak to a pilot then, because pilots will tell you that using the Haversine formula is part of their route planning. They literally have to take into account the fact that the Earth is curved to plan their routes. If you use anything else, if you use anything else other than the Haversine, hold on. If you use anything else other than the Haversine formula to calculate the distances between the point A and point B on Earth, you won't get the right thing. The only way you can do that is by using a spherical trigonometry formula.
So I wouldn't be able to plot my distance from New York City to California without using the Haversine formula, is what you're telling me.
Not if you were using, the maps that are accurate one-to-one to Earth. No.
But what if you use the accurate maps that's going to get you from point A to point B, and when you get there, you say,
road maps aren't
my
accurate.
map was accurate
one-to-one.
because I got here.
Yep.
Say that again.
But each individual section of the map has its own distortion levels to keep it looking flat. But the maps that you use, if you actually to look at them over a large, like all road maps, if you put them over a large area, they actually form a curve.
You have to turn them into, they will form a 3D. I mean, like I said, I've had this debate with several globe earthers. But when we imagine things and we reinvent the wheel, if I was to say, this is theoretically speaking, if I took from New York City to California and I created one road or one railroad that went from New York City directly to California in a straight line path, I can plot my points out without using a 3D map. It would be very, very simple.
It wouldn't be accurate.
Your plot, if you made a railroad that went from one end of the United States to the other end of the United States and made it perfectly straight, you can map out your whole point from point A to point B without using Haversine formula, without creating a 3D map. It's simple. Humans got along using these things for years, and it's so
humans haven't been flying planes for years with using such long distances, and the only accurate way to hold on, Wendell, hold on, please, just one sec. This is a fact that pilots will tell you. The only accurate way to calculate distances between 2 points on Earth over such long distances is to use spherical trigonometry formulas. And I've just been sent something by someone, one of my subs, I'm assuming is a pilot, and I can show you the flight planning software that he's just shown me that shows that it actually uses the radius of the Earth when they're planning the route. So let me just bring that up. I'll send this to you so you can peruse it in your own time, because it's a lot of information to go through, and you may need to Google what some of it means. But this is actual flight planning route from, where was it? He said, from Sydney to Johannesburg, actual plan, and it includes the latitudes and longitudes and the distances between them, which you can only calculate with the Haversine formula.
I get it, but I'm saying that there's other ways to do this. There's more than one way to skin the cat.
You might say there's other ways to do it, but there's only one accurate way to do it.
From what you're saying, because what I'm saying is undebatable. What I'm saying is also facts. But see, it's like Democrats and Republicans debate. No one ever is willing. I'm willing to see your side. So, I mean, trust me, everything that you say, I try to absorb and I try to understand, and a lot of stuff you say, I've already been through these motions. This is the type of stuff we learn in school. But theoretically speaking, like I just said, you say, well, an airplane, you have to do this. Well, let's take that same damn railroad track that I just said that goes from Los Angeles to New York. I'm going to take the same railroad, and I'm going to take a little drone airplane and hover over that train for the whole trip from one point of the United States to the next point of the United States. At that point, I have my road mapped. I have my whole map plotted. I don't need Haversine formula.
But that map, my directions are accurate to the Earth, will be based on a spherical formula.
No, it will not.
All maps are. Every single map. Wendell, hold on. What you don't realize is that every single map that you use is correcting for curve. Every single one. They all include the curve of the Earth in every single map. Every road map that you've ever used in your life has the curve of the Earth in it. So much so that when they built, let me explain. Hold on. So much so that when they built the new sections of the London Undergrounds, the old maps didn't account for the curvature of the Earth enough, and they had to create an entirely new mapping system called the LSG, which was 100 times more accurate to the curve of the Earth to actually be able to plan out the routes. They specifically had to take the curve of the Earth into account when designing the London Undergrounds, because some of the things were so close together. You know, that there was one section, in fact, I've got a little video here. So, when they were designing the new Victoria station, the new line that they had to put in was so close that there was only a variance of about 85 centimeters, right? And if they hadn't taken the curvature of the Earth into the account when they were doing that, then it shows that the drilling machine would have actually gone through the lines that were already there. They had to design a new mapping system that took the curvature of the Earth much more into account to be able to do this accurately. It's part of the engineering specifications of the entire project. You know, it wouldn't have been possible without taking the curvature of the Earth into account. All maps do. It would be, but they distort it a different amount. It literally wasn't possible. They couldn't do it with the old maps that didn't have enough distortion. Well, that had more distortion to make it look more flat. They had to have maps that were more accurate. They could not do it with a flat map. They had to have a map that took the spherical nature of the Earth into account to build a physical engineering structure.
I disagree because, like I said, once again,
you disagree with the engineers that built it.
You see? Like I said,
I'm confused. How can you disagree with the engineers?
See, like I said, it's similar to Democrats and Republicans arguing with each other because the opposite side is refusing to listen. What I'm telling you is that I can build a map myself. I'm not discrediting any engineering feat done by the LSG or any tunnel building or railroad building organization. What I'm telling you is using my own mind. I can devise a mapping system without using any Haberdash formula or without accounting for the curvature of the Earth. I have a sign formula.
Okay, I guarantee you couldn't make a map that doesn't account for the curvature of the Earth that was accurate.
Using without accounting.
The thing is, you're saying that you could. You're saying that you could, but a map will take the curvature of the Earth into account to be accurate.
Well, that's impossible because of what we do as humans is not a fact. It's false because for our size relative to the Earth, even if it is a globe, I do not have to take into account the curvature of the Earth because of my size relative to the Earth. From my size for the map of my country, I would not have to draw a curve. It would be impossible. If I draw your
country, the USA, you absolutely do. The road maps in the USA are based on a spherical Earth.
That's because you guys who created the maps think that the Earth is round.
Are they accurate? Do they get you where you're going? Yes, therefore they're correct.
Of course, they are correct.
And they're based on the spherical Earth.
I'm a flat earther, and if you came to my hometown, I can give you directions over 1,000 miles using flat locations.
And those directions are based on a spherical Earth.
Those directions will be based on a flat Earth.
No, because you would know the directions based on maps that are all based on a spherical Earth.
We can say that we didn't have a map, so we can destroy all the maps that we have. You ever seen the show The Highlander, The Great Catastrophe? We lose all the technology and everything we got, and we're starting from scratch again. Well, when we're starting from scratch again, we got me and you live on one side, and I live on the other side. Now we need a way for us to get back and forth to each other. We're going to plot our directions using a flat map, and it's going to be accurate. And we're going to see each other every time we
and we're going to notice that map isn't flat. We're going to notice that to keep the map on flat paper, we have to start putting distortions onto it that account for the fact that the Earth is spherical. That's how maps work. If we started from scratch and tried to make a map of the entire world, that map wouldn't be flat. That map, if it was accurate one-to-one, would be a sphere.
We can make it flat. That's what I'm telling you.
Well, it wouldn't be accurate then. If you made it flat, it wouldn't be accurate.
There would be some true nail in the coffins for, the
okay, Wendell, for the flat Earth. I give you the challenge then. This is something we've been asking flat earthers for, years. You just said that you could, so please, can you make a
You won't
working
accept
flat
it.
Earth map?
Yeah, you won't accept it.
Oh no, if you made a working
You
flat Earth
wouldn't
map,
do it.
we
I
would
don't.
accept
No
it. That's the
one.
thing. But there is no working flat Earth
You know,
map.
well, see here. Well, see, here's the thing. Guys like you who are actually intelligent enough to start working on this type of thing won't give it a thought. So all of the thought that went into creating the globe model had a lot of money funded behind it. It had a lot of great minds funded behind it. People bash Isaac Newton, but these guys created the greatest formulas in mathematical history.
And they work,
I mean, when you got a group of people like that, yeah, when you got a group of people like that created a model, and even this group of people who made the model said, "Hey guys, our model ain't perfect. This is our
It is
theories,
perfect, though.
this
The
is what we
heliocentric
came
model
up
is
with."
perfect. There's nothing wrong with our model at all.
No, because you just said like some of the stuff doesn't work on the micro level, some of the stuff don't work on the quantum level, some of the stuff don't work
No one said
on the macro level.
Yeah, but the heliocentric model is perfect. It works exactly.
Spiral galaxies, things fall apart.
Not really, no. Dark energy and dark matter things, so, you know.
Yeah, general relativity fall apart, and we
no, not general relativity never falls apart. In fact, it's been proved more and more every time we look into the universe.
You know, the heliocentric model has evolved over the past 50 years, the past 100 years as well.
Science is transitional, yes. When we get more information, science is transitional, yeah. When we get more information, we make things more accurate. That's how it works.
Exactly.
And the only accurate one-to-one map of Earth is a sphere.
That cannot be proven.
It can be because it is proven by the fact that pilots use a spherical map to do their flight planning and they get to where they are going.
So can you not understand that spherical map can be constructed, just like I told you just now?
But that was the, hold on. No, this is where the Haversine formula disproves. Hold on, Wendell. Hold on, please, hold on. This is where the Haversine formula kicks the ass out of it, because if the spherical map was constructed, then it wouldn't correspond one-to-one and give you accurate distances between point A and point B that you can calculate specifically with the Haversine formula, the law of Haversines, right? That would not work if it was just constructed, right? What has been constructed is the flat maps. They are distorted from a curve. That's why all maps are all different, because they have to have different levels of distortion to make flat. But if any map that is one-to-one has a curve, they all do, and it's a fact that pilots prove every time they plan their route.
What I'm telling you is, if we plan a route and we say point A is 1,000 miles away, point B is 1,500 miles away, and point C is 2,000 miles away, we can accurately plot all of these points out through direction simply by traveling to these places, marking the miles, the distance that it takes to get to these places, and now we have constructed a flat map.
No, you haven't constructed a flat map. You've constructed some that shows point A to point B to point C. What you would need to do to get a flat map is then compare that to everything else that's around you and see if it matches up. And what you will find is that it is distorted, Wendell. The only flat maps that you get have distortion. They all have some level of distortion, which is why they couldn't use the original maps that the London Underground were based on, because the level of distortion was too much. They had to reduce that level of distortion, create a new mapping system, the LSG, that had a lot less distortion over a local level, right? But if you took that LSG and showed it on a large scale, you know, it would show a sphere, because it distorted from the sphere of Earth very, very little. No flat map will be accurate. It will never have accurate distances all over the place. And if you took those points that you'd mapped out and mapped them into reality, you would show that it formed a curve.
Like I said, I disagree. I think that we can do
You can disagree all you want, but the Haversine formula kicks the ass out of it.
The Haversine formula may be fucking awesome, dude. I don't know. I never looked at it.
Yeah, it is, because it gets millions of people from point A to point B every day.
Some mathematical constructs are pretty awesome. What I'm telling you is more than one way to skin a cat. And I guarantee you, I can get from point A to point B, just like you say, every day without using the sphere, without even knowing that the world was a sphere. Because if no one taught me,
just knowing where you're going is different to having an accurate map.
I'm going to make an accurate map. That's the only way I can.
Okay, brilliant. Well, I've been asking for 5 years for an accurate working flat Earth map that covers the entire world.
What y'all are asking for, and like I said, that's some of the dumbest things that I hear globe earthers ask normal roundabout people to do, is create a whole world flat Earth working map.
You guys had 2,000 years.
Because that's the globe map that we have now took a lot of people, a lot of great minds, and a lot of money to accurately do. Because in order to accurately do this stuff, you got to actually go to these places and make sure that the distances are correct. You got to make sure that, you know,
it's
from
called
our
cartography.
perspective, we like a little bit of proof. You know, we don't want to say that the North Star is X amount of distance away simply because it doesn't move.
Sorry, did you say you want proof? Well, the fact that the spherical map of Earth works exactly 100% is proof.
It doesn't. I mean, it does.
It
work,
does.
But
it works 100% every time.
But it is a construct, just like I told you.
Well, if it's a construct, then it wouldn't work one-to-one.
It's based on accurate information. So it's
well, then if it's based on accurate information, it must be a sphere, right?
No, because I can base that same accurate information on a flat piece of paper.
No, you cannot.
I can even do one better.
No, you cannot. No, you cannot. You cannot accurately map the world on a flat bit of paper. It is impossible. Wendell, this is what I am telling you. Every single map that is accurate one-to-one over large distances shows the Earth to be a sphere. And they work.
Because you never had a flat Earth to create a world map.
Because there isn't a way to map the Earth on flat. Like, Wendell, what aren't you understanding here? The spherical Earth map works 100%. You can follow it one-to-one and get where you are going every single time. That could only be possible if it is an accurate reflection of reality.
Well, you got some of us that have a problem with some of these accurate reflections of reality, like when we talk about things like Antarctica. Oh, you know what I'm saying?
And, what about Antarctica?
I mean, like I said, I don't even want to get into that because it's a hard debate. I don't know. There's certain things.
Well, just so you know, Antarctica is a real thing. It's a continent on the south of our globe. I've been there. Hold on. Let me just get through it. I've been there personally. Hundreds of people have walked all the way across it. There's a race every 3 years that goes from France, circumnavigates the entirety of Antarctica, and then back up to France. Antarctica is a real thing. There's no big mystery about it.
Well, like I said, I heard Admiral Richard Byrd. I heard him say that there was land beyond Antarctica, big as the United States.
Yeah, it was the other side.
I said, there's certain things about the world that I'm willing to say that I just
what Admiral Byrd meant was the literal countries, you know, the other side. That there is lands beyond Antarctica because the Earth is a sphere, so whichever way you go, there's going to be lands. But also Antarctica is a very, very, very big, well, it's the biggest desert on Earth, you know?
Right, it's supposed to be huge. But like
it's absolutely humongous, yeah. And it's been mapped one-to-one, and people have gone across it using that one-to-one map.
There's certain things that I'm not positive about, that I'm not sure about. And I can't really say it. Like I said, just like the moon, just like Antarctica, I think the Earth has many mysteries. Only 10% of our ocean floors have been mapped out. But you know, you guys telling me that we mapped out the distance to the sun, and we mapped out the distance to this and this, but we haven't even mapped out our own Earth's floor. Only
that's irrelevant. Space travel is nothing to do with submarines.
It is irrelevant, but you would imagine that a person would master his own home before he decided to master, outer space. So I think that the government's lying to us about a lot of stuff. Now, like I said, you could be 100% right. You might be, the Antarctica might have a 24-hour sun.
It does. I've got a video of it.
I've seen plenty of videos of these time-lapse things, but we don't know how accurate and how true.
I've got one that is undisputable.
Well, dude, like
I've also got one that my
there's some
sub sent
things
me of the
that
24-hour nighttime as well.
the things on Earth, some things on Earth, we don't fully understand. I think
Like
the
what?
hardest problem with you guys is the fact that from our perspective and from our size, even if the Earth was a globe, every single thing that we do is going to be based on on a flat surface, on a flat Earth.
Why is
Everything that we're going to do, because our relation to the Earth is our
Pilots
height
disagree with you.
and our
Boat
size
captains disagree with you.
relative to,
Submarine pilots disagree with you.
because you were taught
Navigators
that
disagree with
because you were taught it
you.
in school.
People making big engineering projects like the London Underground disagree with you. People making massive bridges like the Verrazano Narrows Bridge. I'm sorry if I'm trying to pronounce it right. They disagree with you, the engineers that made that. So no, Wendell, not everybody
all
sees
have the
and
same
experiences the
education.
Earth as flat. A lot of people have jobs that take into account the fact that the Earth is curved.
It's because that's what you guys are taught. And
No.
everything
It's
that
what's empirical
you're
evidence.
taught, you don't,
Please don't try and gaslight
don't
me.
scrutinize it.
Wendell, please don't try and gaslight me and be like, "Oh, that's just what you're taught. You think that's like it." No, it's not what we've taught. It's what we've empirically verified. You know, like I said, I've empirically verified that mass attracts mass. That is something that is indisputable. It's been done. It happened in front of my very eyes. You know, there is no disputing that mass attracts mass. You can build the experiment yourself and watch it happen. It's something that's undisputable. Just like the fact that maps that are accurate are based on a sphere.
And see, like I said, it's like a political conversation, because you quick to say
Nothing political about it. It's facts.
See what you just said. Like I said, it's just like you just said. You said, "Don't gaslight me."
Yeah, because
But
you were gaslighting me.
pretty much,
That's exactly what you were doing.
You pretty much gaslighting the whole time, because you're not willing to even accept the fact that a lot of things that
I've not gaslighted you once.
A lot of things that the globe Earth hold to be true can also be found true on the flat Earth.
Name one thing.
Yeah,
Let's focus on that then. Name one thing that is true on flat Earth and the globe Earth.
Like I just said, the downward acceleration of 9.8 meters per second.
Okay. What is the explanation of that if the Earth is flat?
The explanation for that is that you are weightless, and that the downward direction is that gravity is simply the geometry of space.
So gravity's real then?
Many scientists that would agree. Huh?
So gravity's real then?
It's not a force. Gravity,
no one's ever said it's a force. It creates a force.
We're smart enough to know that a horse called by any other name is still a horse. So
hold on. So you agree that gravity exists, right?
I agree that
does gravity exist does gravity exist according to Fg equals gm1 m2 over r squared?
Gravity exists, but because it is the container that holds the fundamental forces. During the Big Bang,
I asked a specific question. Hold on, Wendell. I asked a specific question. Can we describe gravity as Fg equals gm1 m2 over r squared? Is that an accurate observation of what we experience for gravity?
It's a mathematical construct.
No. It's an observation. Is it?
It's an observation that I proved to you. It's an observation that I proved to you earlier that is not accurate to the numbers that you provided.
No, it's accurate.
Because
wait, don't lie to me. You never once proved that it isn't accurate. It is accurate every single time. There is no circumstance where Fg equals gm1 m2 over r squared isn't accurate in the world that we live in.
What is the mass of the Earth? And now you don't have to give me the exact number, but you know what the mass of the Earth is.
Yeah.
I just explained to you that 90 tons, according to what's the name of that satellite company?
Yeah. So 90 tons. 90 tons is less than 1%. Is less than 1% of 1%, and you're not even taking into account the fact that we receive particles and energy from the sun all the time. The alpha decay of the Earth's crust replenishes the atmosphere as well. That 90, honestly, that what we lose to space is inconsequential compared to what we receive and the mass of the Earth.
alpha decay shouldn't add mass back to the Earth. Mass can't be added.
It helps generate more
from an
atmosphere,
outside
actually.
source.
So, you know.
Yeah, but the mass, the differential is the mass doesn't there. The mass is
Yeah,
still
and
the
like
same.
I said, we are constantly receiving. We are constantly receiving. Wendell, hold on. Like I said, we are constantly receiving energy and mass from the sun all of the time. We constantly receive stuff from space all of the time. You know, the amount that are coming in and going out are roughly the same. But
Can you prove that?
Not once did you disprove Fg equals gm1 m2 over r squared. For the mass of the Earth that we have, it works perfectly.
But the mass of the Earth is not the same. It should not be the same. Because
I've just explained to you why it
is.
is. Are you ignoring the things that I am saying to you?
I am not ignoring, but I asked you for some
Well, then I
proof.
just explained to you that we constantly receive energy and mass and particles from the sun. That's a thing that happens.
Right.
The sun spits out shit and it hits us, right?
And how much of it do we get a day?
A lot. A fucking hell of a lot.
No, dude, hell no.
Are you saying we don't receive a lot of stuff from the sun every day?
I'm saying we don't receive 90 tons of mass from the sun every day. We do not.
How do you know?
If we receive 90 tons, because if we did,
Well, that's a
then
lovely
our
claim of yours.
trajectories-
Can I please see the evidence of that claim?
Let me see the evidence of your claim that 90 tons is added to the government.
The sun is constantly putting out energy and stuff that is hitting us. We are. Wendell, stop! Stop! You're over talking me. Stop, please. Right? We are constantly, every second of every day, receiving stuff from the sun. We are all of the time traveling through space, hitting hydrogen, hitting mass, hitting bits of rock, hitting water, hitting asteroids. We are constantly receiving mass onto the Earth. And it works out to be about the same as what goes out. But that is irrelevant to the fact that we can use the known mass of the Earth right now, and it works. There has never been a time when anyone has disproven Fg equals gm1 m2 over r squared. Making an assumption about how much we're losing to how much we're gaining doesn't disprove that the maths works 100% of the time.
All right. So, like I said, I listen that you give your spill because you get on your little soapbox. But at the same note, you just asked me for proof of what I said. And the only thing I asked, I was giving a rebuttal to what you said. You said that the same amount of stuff that is being lost every day is being replaced by the sun and the rocks and the water and everything else. I asked you for your proof of that.
The fact that space is full of it.
Prove it. I can prove that 90 tons of atmosphere is being lost per day. It's a proven fact. Your satellites tell you that. But you cannot prove
and we
opposite.
also show how much energy and stuff we receive each day.
Energy does not add to the mass of the Earth. The sunlight doesn't.
Einstein's equivalence principle would disagree with you, but you know. And again, space is constantly full of stuff, right? Space has hydrogen in it all of the time. It's not empty. We are constantly moving through space. We are constantly gaining mass as we move through space and touch stuff.
So you're telling me that the sunlight adds that much mass to replace it? And all
it's not just sunlight that comes from the sun, is it? It's remnants of nuclear reactions.
Cool. What I'm saying is the weight of the Earth, that all of that shit would have to be equilibrium. The amount of shit coming in would have to match.
All right, here we go. So from satellite observations of Earth and meteor tails, it's estimated that about 100 to 300 metric tons of material strikes Earth every day. And that's from the same science that you have used to explain about 90 tons leaving. So,
how much?
Yeah, well, between 100 and 300 metric tons daily.
All right, so see, and that's still not a balance. So now you're saying on one end 90 and on one end 103. That's still
90 is an average, not a constant. Sometimes it's more, sometimes it's less.
Of course, it's going to be an average. But
yeah,
what
exactly.
I'm saying is the Earth has been there for 1 billion years, and our orbit and our gravity and everything is relying on everything.
Well, our orbit has actually changed over billions of years. Did you know that?
I don't believe that. I don't
Well,
believe
belief
it.
is
So, I mean,
irrelevant.
I
If you're
believe that
arguing
the-
against facts about the heliocentric model, you have to take into account everything we say about the heliocentric model, which includes the fact that our orbit around the sun has not been exactly the same for billions of years.
Yeah, and the universe is expanding, and there's dark matter and all this other stuff that we can't prove. So, I mean, yeah,
we literally have proven dark matter with
you-
measurements.
dark matter to me is an evolution of ether. They got rid of ether and they
That's
came up
just
with dark
wrong
matter.
on so many levels.
That's not wrong on so many, because the idea
It's
of
literally
ether
wrong.
was primitive. The idea of ether was primitive. The idea of ether, that it was something that permeated space to fill this void, that made up for the missing mass of the space. Einstein got
Yeah, they
rid
never
of
said
ether, and
that's
now
what
we-
ether was. They never said that's what ether was. Ether was supposed to be the medium of the universe that allowed light to propagate. It wasn't
that
what you
allowed light
just
to
said.
travel through it, and that's
Yeah.
what I said.
But we've proved that that doesn't exist. You know, that has been disproven. And dark matter is not ether. If you want to call it ether, that's fine. But that's just calling it a name which isn't the same as the thing as before.
It's an evolved idea of the subject, because there's still people out there that believe that light needs a medium to travel through. There's still people out there that think that this is true. So, I mean, regardless of what you say, yeah, there's a lot of smart people that thought that these ideas were viable at some point in time.
Again, science is transitional. Let's focus on what science says now, not what it said years ago, okay?
Yeah, science says now that the Earth is not moving at a constant velocity. The Earth travels around the sun according to the heliocentric model in an ellipse, which would mean that when the Earth is going around its curve.
We've known that for centuries, yeah. We've known that for centuries, yeah.
Exactly. So
that's what our model predicts. Why should what motion should we feel? Can you run me through the maths of the acceleration that we would feel, please?
No, I can't.
Right, okay, well then, if you can't run me through the maths of it, Wendell, then please don't make the claim. Here's the thing. The Earth accelerates by about 3% over 6 months. That equals an acceleration of about 0.0034 meters per second squared. Over 6 months, right? Between the point between when Earth is traveling the fastest and the slowest, that happens over 6 months, and it's a very, very small difference in total, right? So you're feeling that very small change in acceleration happen over a 6-month period. There's nothing in our body that has the ability to detect that.
I mean, like I said, it's nothing that I say that will make you say, hey, man, I can give that right there some thought. Because
I did just give it some thought. I did just give it some thought, Wendell.
All the ideas are based on maths that these people created years ago.
That's been empirically verified. Everything has been empirically verified.
It's mathematical constructs.
No. You keep saying that. You keep saying it's just mathematical constructs. It's not. It's been empirically verified. Please take that on board and don't keep saying it's just mathematical constructs, because it's not. It has been empirically verified to be a fact.
It's not empirically verified to be a fact when we can show several points where this math does not work. Now,
but you've never shown a point where it doesn't work, ever.
I do. Does general relativity work in spiral galaxies? Does general relativity, does all of these maths work in the quantum? No, it does not work. It falls apart in spiral galaxies.
All the maths works for the points that it's made for. Just because we don't have a universal theory of everything that links gravitational, acceleration and stuff with
but you just made a statement that I never showed a point where it doesn't work.
But just because we don't have an equation for something, hold on. Just because we don't have an equation for something doesn't mean that everything that we have doesn't work. Because it does work.
Same thing with the flat Earth. Just because we don't have
nothing about flat Earth works, though. Nothing about the flat Earth works, Wendell. Nothing.
Well, like I said, I can see a picture of a mountain from 275 miles away. That mountain is not tipping away from me. It
wouldn't be 275. Okay, let's talk about that. 275 miles. How many degrees is that on Earth?
4 degrees.
Right, and you think you can notice a 4-degree tilt of a mountain?
I would notice that it's not.
No, you would not notice a 4-degree tilt. I guarantee you, if you put a pencil at the other end of your room, 4 degrees off of vertical, you would not be able to tell.
if I have something else to measure it with, yes. So if I have
So what's your reference? What is your
pencil,
reference to that mountain?
so the horizon and the
The
clouds
horizon will
and
also
everything
be
else that's in
tilting.
the picture.
Wait, the
And-
horizon
and-
is
and-
just an effect of the curve of the Earth.
The horizon means horizontal. The word itself.
No, it
literally
does
means
not mean horizontal.
Horizon.
Horizon comes from the Greek word meaning bounding circle.
Meaning, no, it means horizon.
No, it means bounding circle.
it means-
That is literally where the word horizon came from the Greek word that means bounding circle.
Nah, I studied etymology, man. You know, you may be right, but I think you're wrong.
I am 100% right. That is where the word horizon comes from the Greek word that means bounding circle. The word horizon has nothing to do with the word horizontal at all.
That seems pretty weird.
I mean, it's just a fact, dude. This is what I mean. There is nothing that the flat Earth can explain. Everything that we experience on Earth all of the time, it can all be explained with the heliocentric model perfectly. Everything can be predicted with the heliocentric model. The flat Earth can't even explain how the sun and the moon stay in the sky.
Well, this right here, it says that the etymology comes from bounding. All right,
Yeah,
now, and
bounding circle, yeah.
They have circle, but what it really means is boundary, landmark, marking stones.
No,
bound,
bounding
limit,
circle.
divide, and separate.
It literally the Greek word literally meant bounding circle.
It meant bounding. It meant limiting. Circle
Bounding
is an
circle.
interpretation.
Specifically a bounding circle. That's what a horizon is.
That's what I said. It's that circle is to be implied. It means bounding.
No, not implied. It literally means bounding circle. Nothing, no implications. That's what it means, including the diagrams that show it to be so.
It comes from the word horos, which means boundary, landmark, or marking stone. But regardless, the word horizon and the word horizon and the word horizontal definitely have the same root words and same etymology.
No, they don't. They have no relevance to each other at all.
And that would be retarded as hell, man. It's the same.
No, it's a
word.
fact. Just because they have some of the same letters and sound similar doesn't mean they're the same word.
I get you, man.
It's
like I said, there's certain things that...
It's a fact that horizon and horizontal do not mean the same thing.
All right, man. Like I said, we got two totally definitions of the thing. I see horizon as being flat. You know, I don't think that we can ever measure... I don't think that we can measure a curve on the Earth. I think if we build a boat that was a mile long and we set the boat on the ocean, that the boat would not experience any depth. So I like to think theoretically, if I built a boat a mile long,
okay, theory's fine,
ocean,
but you need to be able to do that.
It should be an 8-inch difference from the tip of that boat to the end of that boat if the boat was in the water, because the curve of the Earth is 8 inches per mile squared. So
no,
if I made a 1 mile boat...
No, it's not. Please stop saying that. The curve of the Earth is not 8 inches per mile squared. That is a parabola. Or it's a way of calculating a chord measurement through the Earth. The curve of the Earth is not 8 inches per mile squared, because that's a single function, and a single function can never come back on itself.
I understand that. When we had our last debate, I explained that right off the bat, and I guess I should explain it to you again just now. That 8 inches per mile squared only works up to a certain distance. Trust me, I get that, but it does work. It works up to a certain distance. I do understand math that thing would curve in on itself if it was to encompass the whole Earth. But it does work for a certain distance. And I'm saying this, like I said, theoretically. So if we was to say 8 inches per mile squared, and if you have a different number, fine. You know, but if we got 8 inches per mile squared, and if I took a 1 mile boat and sat it on the ocean or a flat lake, there should be a dip between the tip of the boat and the end of the boat. What am I looking at?
If the boat was perfectly straight, but, you know, materials aren't rigid. So, however, I'm sure you've heard of Ligo, right?
Yep, Ligos, yep.
Yeah, the laser interferometer gravitational wave detectors all around the world.
Uh-huh.
Well, great thing about Ligo is that the arms of them are so long that the construction took into account the curve of the Earth. The distance, like, above sea level along the entire thing is the same. But when you go to the end of the arm compared to the beginning of the arm, they had to do precision pouring of concrete. Excuse me. Because it was so long and so straight after construction that the end moved away from the surface of the Earth, as predicted by your thought experiment. It's literally why the LIGO installations took years and years and years of calibration, because they had to make sure it was perfectly straight, but that's hard to do when the Earth is curved. So that's what you're suggesting has already happened in several facilities around the world.
Like I said, man, a lot of that stuff I would have to research on myself. A lot of stuff that I scrutinize, I understand that you may not scrutinize. But there's already certain problems that I saw with what you was telling me just now. But like I said, I need to sit and actually think about it. But I need to look at the length, the actual length of those arms, and I need to look at how light would react shooting down those tunnels with this curved fixture. I mean, there's certain things, because I mean, if it's curved too much, then if I shot a light straight down, and if I shot the laser straight down, it would end up hitting the wall instead of going straight down the original path that it's supposed to of this 1 mile tunnel. So there's a lot of things that I need to think about when it comes down to, you know, like the LIGO facility. I never researched the LIGO facility itself.
Really,
I know what LIGO does.
Yeah.
I know what LIGO does. I'm definitely not an architect, you know, but I do have a friend of mine who is engineer, built dams in Canada, and he's not a flat earther. I don't have a conversation with him about flat earth. He'd probably think I'm a wacko, but I ask him general questions, and like a question like, could I make a map of a road from one end of South Carolina, one end of the United States to the other end of the United States? Say yeah, it should be possible. Why not? You know, I mean, and the stuff like that you say that you have to account for the curve of the Earth.
But you know, they have measured the United States, right? They've literally measured it and figured out it was curved.
Yeah, they measured and figured out that it was. How could they do that, dude?
With surveying, you know, they use
one
triangles, right? They use triangles on Earth to measure over great distances, right? And when they did that across the whole United States, what they found was that every single one of their triangles added up to more than 180. Every single one, which meant the only way that could happen was if it was on a spherical surface. And they used their data from just the USA to go, well, okay, if this is what we figured out here, then this is what the radius of the Earth should be, and it matched. But they weren't the only people to do that. That's been done all around the world, in the United Kingdom, in Asia, you know, in Europe, in Russia. They've all had surveyors measure it using the same method. And all of the triangles have spherical excess. They all have more than 180 degrees. So they have done what you're saying. They have measured coast to coast in the States and found that it's curved.
And they all have more than 180 degrees.
Every single one, yeah.
Like I said, I'm going to have to look at that as well. In my mind,
mctoon.net/r.
If I'm on, if you where you're at and I'm at where I'm at, and we know our height from sea level, it's going to be the same for us, man. So, I mean, it's flat. The distances between us and each other, we can map out using a straight, flat direction. You know,
yeah, it wouldn't be a map, though. If you were to use a map, it'd have to be curved.
What is the definition of a map?
What is the definition of a map?
Yeah, because you just said it wouldn't be a map. That's retarded, dude.
Yeah, just like going point A to point B and putting a line. That's not really a map. That's just kind of like...
You could say not really.
It's a very, very basic form of navigational, you know, it's almost a map, but it's not really a map, and it wouldn't match with everything else. That's the thing. The only map that takes the entire world into account that is accurate is a globe.
It's the globe.
And it's accurate, Wendell. Like it works 100%.
Because we have never devised a flat map. There's no
because they don't work
for us right now, and that's all, and that's why.
But all right. So why would you do a flat map if we've got a globe one that works?
All our maps started off as being flat. It's just that we weren't able to put them all together.
Yeah, when you put them all together, it's a globe. Weird, right?
You can do it without putting them all. You can make that without putting them all together.
Yeah, but when you do put them all together, you get a globe, right?
No.
Yeah, you do, because the only accurate one-to-one map that exists is the globe. No other accurate map exists that covers the entire planet. All of Earth.
Because the people who created the globe thought that it was right. Okay?
Yeah, and look, Wendell, come on, think about what you're saying here. It's accurate. It works. If it works, then it's right.
It is accurate. It can take you where you need to go. For us,
because it's one-to-one accurate.
You cannot use a globe to get from point A to point B.
Yes, you can. Pilots do it all the time, every time they plan a route.
Pilots are using digital interfaces to plan their routes.
Of a globe, yes. It's all based on the globe.
The digital computer is doing that for them. Now, before pilots...
And they have to use the Habersign formula to actually accurately calculate the distances between point A and point B on the maps they are using, because it is a globe. Wendell, I need you to think hard about this. The only accurate one-to-one map that exists is a globe. If it is accurate, if it gets you where you're going 100% of the time, then it must match reality. Think about it.
I have never used the globe to go anywhere that I needed.
You've never had it had to go around the entire world. But this, please listen. You're skipping over the only accurate thing that covers the entire Earth. The only accurate map that covers the entire Earth is a globe. It doesn't matter what you've used. That's irrelevant. The only accurate one that covers the entire world is a globe. Therefore, the Earth is a globe.
And whenever you're using it to travel, that globe mysteriously turns into a flat piece of paper.
To do that, the map has to have distortions, which is why maps have keys.
Right. So
so think about it. If you have to distort a map to make it flat, and the only way that it has no distortions, if it is a globe, then what is it matching reality of?
What is the distortions with the map? When you travel across country, across England, what distortion do you have with your map?
As I explained earlier, with the London Underground system, they were using the maps that were a distortion of the globe, but the distortion to flat was too much. They'd made it too flat, which meant the distances were inaccurate. They had to make a new map that had much less distortions on, by a factor of like 100, to be able to accurately map where they were putting the new tunnels, right? They had to have less of a distortion. And it was a distortion of about 0.01%, so that they could have it flat and to do what they needed to do. But it was still based on a sphere, right? But the only accurate map in the world, that covers the entire world, is a globe. That's it. That's not a disputable thing. That's a fact.
We will never use, like I said, the globe. To me, the globe is not a map. You can't use the globe to get from point A to point B.
Wendell, why do you keep resetting? Pilots use the globe to get from point A to point B. Don't say it doesn't happen when pilots do it every single day.
And before pilots had those digital interfaces,
who cares? They still use the globe.
Before pilots had those interfaces, they didn't have to use the globe.
Yes, they did. They always used the Habersign formula. Whenever there has been Wendell, listen and understand. For the entire history of long-distance flight, forever, they've had to use the Habersign formula to calculate accurate distances. All the time. Whether they had an interface or not, that is what they used. The interface just makes it easier to be able to actually display the entire globe. But pilots have always used the Haversine formula for long distance travel. They have to. They absolutely 100% have to. And pilots nowadays, every single one of them, their entire mapping system is a globe. It's accurate 1-to-1, the entire world. The only way that it can be accurate 1-to-1 is if the Earth is a globe. Don't worry about anything else. Just focus on that fact. It gets you where you need to go 100%, and it is a globe.
I can get you where you can need to get 100% of the time without a globe. But hey,
no, you couldn't. You could not. You could not get me from one side of the Earth.
To you.
All right, hold on, Wendell.
That matters to you.
Listen, it does. You could not get me from one side of the Earth to the other without taking into account the fact that the Earth is a globe. You couldn't do it.
Say what you want to, but I could.
No, you couldn't. Because the maps that you would have to use would be based on a globe, or at least distorted from a globe.
People did it. People did it before they had a map of the globe.
And they got lost all the time. They got absolutely lost all the time. They got lost all the time, didn't they? What happened when Christopher Columbus was trying to find... What happened when Christopher Columbus was trying to go a different way to get to India? He discovered America. But he knew the Earth was a globe, but he didn't know those bloody islands, that big, massive continent would be there. But they still based their journey on the Earth being a globe, even hundreds of years ago.
And he did. And you also had people who thought the Earth was flat. You had people that mapped out solar eclipses and stuff on flat... with the flat Earth society.
No one has ever mapped out solar eclipses with a flat Earth.
I mean,
that's just not a thing. That is a straight up lie. I'm afraid.
They're based on patterns. So they were flat Earth societies that understood.
No, there was not a flat Earth society ever that mapped out solar eclipses. And the only way that you can accurately predict a solar eclipse down to the millisecond and millimeter is by using the heliocentric model.
Say that again. I had a phone call. I couldn't hear you.
No one in history has ever used a flat Earth to model out where exactly solar eclipses will be. The only way that you can accurately, to the millisecond and the millimeter, predict where a solar eclipse and when it's going to happen is by using the heliocentric model.
I thought the Ptolemaic model predicted them using the geocentric model, right?
No, not very well, no.
But it did. You said not very well, but like I said,
they had to have weird explanations for retrograde motion and stuff, which didn't make any sense. So the model didn't work. They could say, "Oh, this happens," right? But they didn't have an explanation for it. They didn't have a way to predict it happening. They could just see it happening. But the only way to accurately predict what's going to happen hundreds of years into the future is by using the heliocentric model. There's no other model that works for things like that.
Right. Hey, like I said, man, it's like a debate where we will never see eye to eye, because in my mind, even if you're right, listen at me. Even if you're right, I'm willing to accept that the Earth is a globe. If I'm observing the Earth from outer space or whatever, I'm totally willing to accept that the Earth is a globe. What I'm telling you is that if we're focusing on the view of the observer, which is me, everything that I observe in my seeable nature is flat. What I see is the stars moving around.
Everything that I observe shows that the Earth is a curve. The Earth is spherical. Everything that I've observed throughout my entire life, the experiments I've done, the places I've been, the things I've done, shows that the Earth is a rotating globe.
Well, like I said, in order for you guys to prove that the Earth is a rotating globe, you have to have a PhD. There's no something that
I've only got 2 bachelors. I do not have a PhD, and I can prove the Earth is a globe.
You cannot prove the Earth is a globe. What you
I can, because I've measured the rotation and shape of the Earth, so I can prove that the Earth is a globe.
How could you measure the rotation of the Earth?
With a pendulum. It's pretty easy.
With a Foucault pendulum?
Yeah. Pretty easy.
And the Earth turns under the Foucault pendulum?
It rotates independently of the swing of the pendulum, yes. And I've done this myself. And the great thing about a Foucault's pendulum, is that when they're working and set up properly, you can actually use the deviation of the swing to calculate your latitude on Earth.
Latitude on Earth, yeah. That's experiments we did as kids. We did those experiments as kids. Now, my only upheaval with those type of experiments is what is the force that's causing this pendulum to move in the manner that it's moving?
Coriolis force.
Because us as kids, when we start to ask these questions, which used to be good in science, obviously now in sacrilege.
Questions are great in science. Science is about questions.
We would ask a question and say, well, if the Earth is turning under the Foucault's pendulum, why doesn't it turn under, let's say, a helicopter that's hovering above the Earth?
Okay, right. Okay, let's stop there. Wendell, that is a humongous straw man. Is a helicopter a pendulum?
Of course not.
Is a helicopter attached to the Earth via a pivot point?
Of course not.
Does a pendulum use the atmosphere to generate lift?
Does it use the atmosphere to generate lift? No.
No. So you cannot compare how a helicopter hovering above a rotating Earth in the atmosphere that rotates with the Earth to a pendulum which is freely swinging in 3D space. They are not the same thing and will not have forces applied to them the same. A helicopter will have zero Coriolis forces applied to it because it doesn't have a lateral movement of any kind. The only way you can get Coriolis forces applied is if there's some kind of movement that will then have the Coriolis forces imparted to it. A helicopter hovering above the Earth doesn't have any lateral movement for a force to be applied. So they're not the same, and it's a straw man to say that. What you expect to see with a helicopter hovering is for it to hover in place. That's what we predict. What you expect to see with a pendulum swinging is a drift being able to correlate to your latitude on Earth, and that's what we see.
Well, again, like I said, you guys like to say, well, yeah, man, that's a straw man or this or that.
It is a straw man. It's a complete and utter straw man of my argument.
Well, to us, all right, like I say, I never say I'm right about 100% about anything. But if this helicopter is hovering above Earth and the Earth is rotating under the helicopter...
No, the Earth doesn't rotate under the helicopter. That's a straw man. The atmosphere rotates with the Earth. Therefore, the helicopter rotates with the Earth. Nobody has ever said the Earth rotates underneath a helicopter. That is not our claim. So you are just talking a random straw man.
Well, that is not your claim, but in the same aspect, you claim that the Earth is not a closed system. So, if the Earth is not a closed system,
the Earth is a closed system.
If the Earth is closed and you can't get into outer space and nothing can come in, and
I don't think you know what a closed system is, do you? A closed system doesn't mean you can't get out.
Yeah, I know you got to reach Mach 3 to get out. Trust me, all this stuff
that's just not. Right, dude. Right, seriously, please look into what a closed system means. It doesn't mean what you think it means.
I'm not talking, dude. I know what a closed system is.
Clearly, you don't. Right. Define a closed system for me in the concept of physics.
In the concept of physics, closed system. Well, in relation to the Earth, a closed system is everything that's being contained and being held in.
No, that's not what a closed system is.
Okay, so what's a closed system?
A closed system is something that can, in general, receive only energy into it and out of it, and not matter, right? Earth counts as a closed system because the amount of matter leaving and entering it is almost the same. So that's all a closed system is. There's nothing about a closed system that says you can't actually go into space. It's like, it's just you not understanding. But let's get back to the pendulum. Let's get back to the pendulum and the difference between the pendulum and a helicopter. A helicopter rotates with the Earth because the atmosphere rotates with the Earth. All right, that's a fact. That's our model. That's what happens. So the prediction is a helicopter will just hover in place as the Earth rotates and takes the helicopter with it. But a pendulum is swinging underneath the pivot point that is attached to the Earth. And that swing maintains its original direction relative to the axis of Earth's rotation. And as you move away from the poles, you change the angle that that axis is relative to, meaning you change the period of time that the pendulum will take to rotate to 24 hours. And that's Coriolis forces being demonstrated exactly as predicted. The whole, oh, well, why doesn't a helicopter move? Have it rotate is a complete and utter straw man and nothing to do with the argument of a pendulum. We need to focus on why. We need to focus on why the pendulum does what it does, as predicted by the heliocentric model. And I've never used a straw man.
I agree. I mean, you think that it's a straw man, but for me, things that are moving, if let's just say, if anything is detached from the Earth's surface, all right, and we're not locked in to the surface, then the surface of Earth should move under me. So
but the atmosphere moves with the Earth. They are the same. They are locked together. Just
like if you're in a car, all right, and the car's traveling at a constant speed, you would not notice if we black out all the windows. You wouldn't notice the motion of the car. As long as the car is moving
this has got
constant,
nothing to do with the pendulum and the helicopter.
Listen, it's got something to do with the helicopter if you can listen instead of, just keep jumping into it. Now, if we remove the top now, while that car is moving and you're inside this system in this car, if you jump up and down, then you're going to land right back in your same spot.
Yeah.
But if we rip the top off of the car and we introduce outside things, you're not going to. So when you jump, you're going to be
there's nothing outside the Earth, though.
And you're going to outer space.
Yeah, and vacuums don't suck. The atmosphere doesn't just go off into space for no reason.
I never said.
Right, all this is irrelevant. Wendell, stop. All this is irrelevant. Stop, Wendell. All this is irrelevant. The fact is, the atmosphere rotates with the Earth because of friction and viscosity and gravity. All right, the atmosphere rotates with the Earth. Therefore, a helicopter hovering rotates with the Earth. That's it. There's no more to discuss about it.
What about the wind?
The wind is independent movements. That's different. Right? Let me explain. An entire weather system will still be rotating with the Earth, but within that weather system, there'll be different areas of pressure, changing the temperature, making atmosphere move from one point to the other. But that's why we get cyclones and storms, because that entire weather system is also rotating with the Earth. But because within that weather system, you've got freely moving particles of air, because they're going from high pressure to low pressure, you actually have Coriolis forces applied to the air, which makes it turn, and then you get hurricanes because you keep getting Coriolis forces applied to the air that is moving, and it makes it rotate. So the fact that wind exists causing hurricanes is another example of Coriolis and proof that the Earth rotates. But again, none of that is relevant to a helicopter. If it is a perfectly calm day, right, and the helicopter is hovering, then it is in the atmosphere, and that atmosphere is moving pretty much in lockstep with the Earth. The helicopter and the Earth are the same reference frame.
The helicopter and the Earth are the same reference frame, dude. I understand all of it. But
so there's no reason at all the helicopter should ever have the Earth rotate underneath it.
If Earth is open, if space is real, then it should. So I mean, but no, you're right. I'm not even.
It shouldn't, because the atmosphere still rotates with the Earth.
Yeah, all right. You're right. So, in closing, I just want to ask you a question. All right, because like I say, we're gonna have to agree to disagree. So, in closing, I just want to ask you a question.
Yeah.
At what point can me being a human observe the Earth rotating? Or how would I, as a human, be able to see the Earth rotating, be able to see the curve of the Earth, or be able to feel the speed of the Earth moving through?
You would never be able to feel the speed of the Earth moving. There's nothing in our bodies that has a function that allows us to do that. You just don't feel that because there's no physical mechanism for us to detect it. But to see the curve of the Earth, to see the rotation of the Earth, do measurements, do experiments. Simply doing the Foucault's pendulum experiment will allow you to see the rotation of the Earth. If you want
I've done the Foucault's pendulum.
And did you use the deviation to calculate your latitude on Earth?
Yes, we did it.
Well, then there you go. You saw the rotation of Earth, Wendell.
Like I said, I did this as a kid, and like I said, for me, as an adult, especially as an adult now, I don't know exactly what forces are acting on that Foucault's pendulum.
Coriolis forces, I told you.
But yeah, I know that Coriolis is a fictitious force. But hey, you're right. So what my question to you was, how can me personally, at what height do I have to go into outer space in order to literally watch the Earth rotate?
Well, to watch the Earth rotate, you would have to be orbiting at a different amount. Like, you would have to be.
You would have to be an inertial observer.
Yeah. I mean, you could be any height. It doesn't really matter. But for that to happen, you'd have to be an astronaut, go into space, and be countering the Earth's rotation, right? Because you're going to have that momentum when you go into space still. So then you'd have to counter that momentum and counter the Earth's rotation to be able to see it rotating underneath you, you know? And unfortunately, to do that, Wendell, you would have to be an astronaut and probably go, towards the moon or something. I reckon people on the moon, when they were looking down at Earth, could notice the rotation of the Earth. So, yeah, there you go. That answers your question. Become an astronaut and go to the moon. There'll be a lot of openings for that soon.
Yeah, if I was an astronaut, we wouldn't be having this conversation, buddy.
No, because you'd know the Earth isn't flat. Right, how about I read super chats and then we get out of here for tonight?
Say that again?
How about I read my super chat, see if there's any questions for you,
yep.
And then we shut down for tonight. It's got to be heated, but thank you very much, Wendell. It's been fun.
Oh, yeah.
Skidmark McGee, $5. Another $5 just for putting up with the idiots and bringing us entertainment. Hey, it's what I live for, man. And then Skidmark McGee also became a new member. Welcome to Scrappers. Fucking awesome. Alison, $2. Haversine, no flat Earth alternative. Bam, flat Earth debunked. Yeah. I want to get you to speak to a pilot about the Haversine formula, Wendell. That would be good.
Yeah. I mean, it's great. It's entertainment because, all of your viewers, man, they all globe earthers. None of them going to have my back. Like I said, I went through that the last time. None of them can speak to the fact that, that gravity is actually the geometric shape of space-time.
Yeah,
the only reason
that is irrelevant
in general relativity.
To us here.
In general relativity, we're only moving because we're moving through time. You got to be standing still just to be moving.
Yeah, but again, all that's completely irrelevant to us that lives in the Newtonian world.
Exactly. Yeah, y'all. There's two types of thinkers.
And we can demonstrate that gravity exists, and there's an attraction between masses.
There's going to be a way in the future to prove whether the Newtonian way of thinking is right. We're going to take that electrical charge and we're going to drop one into free fall, and we're going to leave one at rest. And if the one at rest generates the charge, then general relativity is right. If the one that's going through
general relativity doesn't say that Newtonian gravity is wrong. It's just a different way of
explaining it. No, exactly.
No.
It's a little different ways of seeing it. Trust me, I understand it. And a lot of it works on the flat Earth. So.
Right, nothing works on flat Earth. Many Karen for 15 shekels. For me personally, people think there's a personal definition of gravity are defined as idiots. Ooh, harsh. And then many Karen, another 6 shekels. Catholics have mass. Yes, they do. Very boring mass. Lord Illuminous Pooh for $2 says, no, bad Flerf, no. And then Tim Tully for $5 says, respectfully, Wendell, where did you get your physics education?
Ask him respectfully, where did I go wrong with anything that I said? I didn't give you any bad numbers. I gave you my opinion. No, I gave you my opinion.
But that wasn't the question. The question was, do you have a physics education? Like I've got an A-level in physics, and then I've got a bachelor's of science in physics. So what's your physics education level?
I graduated with associates in arts from a tech school, dude. I don't have a physics education.
Right,
I just got
that
pretty
may be part
IQ.
of the issue. Professor Philip Bell in the chat says that he would like to talk with you sometime, and he actually put something on the moon. Well, he crashed something into the moon. So
tell him I would love to talk to him.
Okay, we can absolutely arrange that. That sounds good. James Weber for $50, dude. Oh, all the love, thank you. He is trying to ignore gravity involved in weight. He thinks weight is something separate. He won't say density, but that's what he wants to say. He is denying reality, hammering on 9.8 meters per second squared. Don't let him draw you off. Yeah, I think we got through the weight, the weight versus mass thing. And I explained to him that your weight will be different based on your position on Earth. And hopefully
your mass won't. But,
your mass won't never change, but
the
the fact that your weight does is an important thing. Right?
Why? You don't.
Because why would your weight change if there wasn't a gravitational acceleration change?
Why does that have to be taken into account when we're looking at Newton's laws of motion? When we're looking at F,
we're looking at Newton's law of gravity, which explains why there is a difference in our weight based on the poles to the equator. So
he created a gravitational constant, which the scales have to be calibrated.
Well, he didn't create gravitational constant; that was derived.
Ask the same guy who put that question. Ask that guy, how do you measure mass? And that's the only question. That's the only thing he needs to know.
With a balance scale,
mass is not going to change.
Easy. You measure mass with a balance scale, and
right.
That's
it. So we don't need weight.
And you measure weight. Yeah, you do need weight because a lot of things measure in different ways. And whether you need weight or not, Wendell, the fact is that weight is a thing that exists, and it changes when the gravitational acceleration changes.
Right.
So that's a thing that happens. Triple Cow K, who's been a member for 10 months, thank you very much, says, Wendell, is every physicist ever lying, or are they just dumb?
No, most of them are geniuses. They just evolve off of each other. I never said Isaac Newton. I use Isaac Newton's equations all the time. Some of the simplest shit that you ever learn, and they work all the damn time.
Yeah, they do, especially that gravitational
never said that
law.
These people were idiots. You're the idiot for thinking that I'm an idiot because I disagree with somebody. I never said that I was right about 100% that I said, but I have the right to disagree and do my own independent investigation.
Absolutely, and I would never call you an idiot. I would never call you an idiot for disagreeing. Right? But I would call you an idiot if you were willfully ignorant. And that means refusing to even consider the other side, right? And that's when I call flat earthers fucking retards and idiots and morons and stuff, is when they are willfully ignorant, right? Well, you may have scraped that today, Wendell. You did quite a few Flerf resets, right? But if you look into some of the things that I've said, especially the Cavendish experiment, Haversine formula, that will prepare you for your conversation with Professor Philip Bell.
Yeah, tell Professor Philip Bell, let's do it. I'll be a little bit more prepared for him. I'm gonna have some mathematical numbers set up.
He likes maths quite a lot. That's what he does. Right, Phil Bell, hit me up on Discord, and we'll get that sorted, bud. Okay. Lord Illuminous Pooh for $5 says, I hate penis enhancement emails. I got 10 today. 8 of them from my girlfriend, and 2 of them from my mum. That really hurt.
Damn.
Weeboo Metalhead, been a member for 26 months. That's more than twice round the sun, guys. Says, ask him about the Edge Gate from MC Toon's Lion's Den. Yeah, I haven't yet had the pleasure of watching that MC Toon debate, so give me a while. Draco Fire, my favourite under 20-year-old, who's been a member for 25 months, says, falls from a plane. It's a straight line. There's no force affecting me. That's a joke. Siggy Sigwald, been a member for 10 months, nearly once round the sun. I wish I was as confident as Flerfs are, hashtag facepalm. Connell Silver for $10. We lose 90 tons of atmosphere into space each day. The mass of our atmosphere is 5.5 quadrillion tons. That means we lose less than 1% in our atmosphere each day. Not a problem. Yeah, then there's how much we gain as well.
Yeah, because he's not thinking about over the time. He didn't do any math. He's the one's face palming, but hey.
Oh, but he did do the
didn't
math.
Do any math. Doesn't have any accurate numbers. Yeah, 90 tons a day seems minuscule, but when you put that over a billion years, that's a lot of mass.
But when we're receiving, almost 100 tons a day as well, it's like not really.
And if there's a difference between 10 tons over a billion years.
Oh, remember that 90 is just an average. Sometimes it's more, sometimes it's less. So it all balances out roughly.
I got you. Right.
Anyway, Draco Fire $2 says Phil Bell wants to speak with Wendell someday. Don't worry, Draco, we've got that sorted. ZScout1288, who's been a member for exactly half of the way around the sun, says, love your streams, keep up the great work. Well, I fucking love you, young man. Sir, ma'am. I didn't assume your gender, I'm sorry. Yeah, I love you, absolutely. Thank you very much for watching. I love doing these streams, and I may have another 2 tomorrow. That could be fun. Thank you very much. Mr. QTube, first name Fa for $5, says, this guy can't even say Neil deGrasse Tyson's name right. He's not qualified to debate this topic. Just so you know, Wendell, I've got a video that I've partially scripted that I'm putting together, and the title of the video is Neil deGrasse Tyson was wrong about gravity. Here's why.
Awesome.
I hope it's not going to make him angry at me. Mr. QTube, first name Fa for $2, says, you correct dips every time you debate a Flerf.
These guys are amazing, man. They 80 IQ, man. I love your viewers with the 80 IQs. Most of them can't grasp half of the conversation, but hey, they can make a joke.
Yeah, mods, yeah, good job. Please, there's a few of the spam bots in there. Get rid of them if you can. Thank you. Alison for $5 Australian says, you don't want to argue about sextants because you haven't researched them enough to understand them, yet you open your mouth on the shape of the Earth. Ooh, he's saying you haven't researched the shape of the Earth there, Wendell.
And no, like I said, this is an educational fun topic for me. I'm not a traditional flat earther. I never seen the guy Durf, what you talked about earlier.
Yeah,
I never
DIRTH,
watched a lot of flat earth debates. I do this based off of the Facebook group, and I see a lot of Globers bashing the flat earthers, and I think some of the flat earther arguments are pretty viable, even if they're wrong. Doesn't mean that these people have a below 100 IQ like people bashing them. Huh?
They can't be viable.
No, I mean, like I said, you're misconstruing what I'm saying. Like, what I mean by viable is mean that I can understand why they understand some of the things that they say. And your globe is like, oh, face palm. The Earth would not fall into the sun. There's no need for no other force. Well, there's a reason why these guys are questioning that.
Because they never studied physics.
Simple. They can study physics, and we pass physics. A lot of people in that group.
Then if they did that, they wouldn't ask these questions.
They would. They asked those questions of physics. They passed because they knew what they had to write on that paper.
No, that's not how it works. So you have to demonstrate your knowledge works.
I graduated at the top of my class, and a lot of stuff that my teachers taught me, I felt was bullshit. But I could easily pass those classes, top of my class, gifted and talented, no problem, because it was just simply based on memory. So. It wasn't based on thought; it was based on memory. So I mean, most of this shit.
This is why you've never done higher education, right? Anyway, so Cody Payne, $5. A flat earther with manners and some scientific literacy. Craig, I think this one could be saved. We'll see. Talk of Professor Bell could be good. Mr. Blocktron, been a member for 8 months, says, okay, while this Flerf is showing relatively high levels of incredulity, he does recognise some semblance of scientific reality. I think there's hope. Couple of fans there, Wendell.
They still on your side, but I get you.
Of course they are. Eon Dust, member for 13 months, says, well, that's just over once around the sun. Where are these guarantees coming from, honey? You talks like you've done this, but I doubt you have. Yeah, I think he wants to see your working flat Earth map.
Yeah, and like I said, I'm not going to guarantee you guys that I can give you. I'm pretty sure it's been guys smarter than me that tried to do this. So, I mean, I'm not sure, but I know if I make a road from here, I can make a flat Earth map of the United States. I can make a flat Earth map of my state. A flat map of my state, a flat map of my country. But hey, I get you.
Lord Linus Pooh for $2 says, yes, that's what we're taught because it is correct. LB Stuff, Things and More for $2 says, Wendell, why is there day and night at the same time?
Why is there day and night at the same time?
Yeah.
Well, what the hell does he mean by that?
Well, right now for me it's 3:57 a.m., but in Australia the sun's probably heading up towards midday, right?
But that can work out on a flat Earth or a
well, no, because you'd be able to see the sun all the time.
A question. Huh?
You'd be able to see the sun all the time if the Earth was flat.
No, you wouldn't.
You would. I made a
Because your vision
simulation.
would only be fun. So when you look off and if you
Where's my
look
simulation?
straight into space, if you go stand up 500 feet and you go look straight into space, are you going to see stars at the horizon?
Sorry, what was the question? I'm looking for something. Say that again.
If you stood 500 feet up and you look directly straight ahead of you, are you going to see stars in the horizon? On the horizon.
If it's
Have
nighttime,
you ever
yeah.
seen a meteor? Have you ever seen a meteor shoot up from the horizon instead of
Lots.
shoot down?
Yeah, all the time.
Oh, okay. I mean, I don't know. I've never seen that.
I mean, it literally
Never
happens
seen
all the
that.
time. Like, I never understand why people say that doesn't happen. Like, it happens all of the time.
I mean,
every year at the PC
of course, people
shows.
like that. I mean, of course, people like us are going to say, "Why does it never happen?" Because we've
But it-
never seen it. I've seen meteor shower. We just had a
But it
meteor
does
shower
happen
the other
all
day.
of the time.
And
I don't know why you would say it doesn't.
I said, I've never seen it. I asked a question. I said,
Right.
have you ever seen?
Yes,
a
I
meteor
have, and
shoot
so have
up?
lots of
And
other people.
And like I said, you know, shame on me for not researching you guys and watching some other flat Earth debate videos, because some of these topics may have already been brought up, and I could have already researched them a little bit more. But me personally, I've seen dozens of meteor showers throughout my life. Just had one the other day. I've never seen a meteor shoot the opposite way. I've never seen a meteor shoot up from the horizon.
Okay, well, I have. It happens all the time. So I can send you a bunch of videos of it happening if you want.
I believe you. I can Google it.
Atlas6355, $199 says, getting info from satellites that orbit the Earth. Yeah, brilliant. Astronaut66 for $5. What mechanism on the flat Earth makes it possible for us to determine our latitude by the use of a pendulum?
I don't have an answer for that, bro.
Nope, no flat earther ever has. And I've still got the £10,000 challenge for a flat earther to explain it to me. Connell Silver, $5 says, Wendell, retarded and stupid are the two more words that have nothing to do with each other. They are not the same thing, so don't use them as such. I think that was me using them, actually.
Shut up. Yeah, tell that guy to shut up, man. Be the damn dick. Quit being a pussy, dude.
Eon Dust, $5 Australian.
mean that in a
Snake
good
and
way.
snack have mostly the same letters, but you wouldn't want to get them mixed up, honey. No, I hate snakes. That's like, I don't have, like, yeah, I do have a phobia because I've got a phobia of snakes, right? I don't know why, but I completely freak out. Spiders couldn't give a fuck, right? But snakes freak me the fuck out, like full on. And when I was living down in Gosport, south of England, and we had like a patio door that opened onto our garden, and the garden had just been cut and had the door open. And I look over and I see just this little thing coming over the door frame into the front of the garden, you know, and I don't really pay attention. It's coming into the house. And I was playing on my PlayStation, and I look over and I look back, and then I kind of do a double take and realize that it's a snake. It's only like a wee grass snake, like a little addery type thing, right? But that's it. My brain's just gone into "you're gonna die" mode, and like I had to get next door, a dude from next door, to come in and pick up this tiny little grass snake and take it away because my body had just shut down. You know, I couldn't speak. Like it was, and like. It's a stupid thing because I know at the end of the day that snake probably could never even hurt me, right? But like something in my brain was like, no, you need to just turn off. That snake killed me for it. It was crazy. But I think that's kind of a holdover from us being hunter-gatherers and stuff, right? So back then, a little scurry, you know, spider or a little, you know, snake moving could mean death for you, right? And I think that that kind of recognition of that tiny little scurrying movement has stayed in our brain as some kind of genetic memory, which is why people have phobias of spiders and snakes. That's what I think, anyway. Little side story there.
Maybe.
Anyway, I'm fucking scared of snakes. If you wanna screw me over, just bring some snakes. I can never go to Australia. Lord Luminous Pooh for $2. His argument is paper is not flat. His argument is paper is flat, not the Earth, for fuck's sake. Yeah, get the map, Wendell, then we'll be happy. Mr. QTube, first name Faf for $2, says, it's listen to me, not at me. Sorry. Paul Steigerman, who's a new member. Welcome to Destroyers, you fucking awesome person. And then my favourite robot in the world, Rachbot, $20 Australian, says, it's been a great morning of FTFE. I'm so happy. There's loads more coming over the next few days, Rach. Thank you very much. Pat in the chat for $5 says, hey Craig, sorry missed most of this debate. Hope you're still somewhat sane. Hey 77 conspiracies, hashtag thanks Bobs. Yeah, I'm mostly sane, don't worry. Nearly done with the super chats. Obi-Wan for $20 says, Wendell, buddy, I'm an old F-14 pilot. Nothing you said about flying and navigation are right. I've flown high enough to see the curvature of the Earth, and I've flown near enough to Antarctica to know that it's there and not a wall.
Hey, tell Obi-Wan I ain't gonna debate him because his name is cool as shit.
Yeah.
So, okay.
Yeah. So, if someone comes up to you and says, hello there, what's your response?
Oh, that's Obi-Wan all day, brother. Hello there.
So if someone comes up to you and says, hello there, what do you say back to them?
Shit, you got me stumped, man. I don't even know
what
was the response.
General
man.
Kenobi.
You said,
that's the whole meme. Hello
Grievous?
there. Yeah. Grievous when
fucking Grievous?
Yeah, when
Grievous,
Kenobi meets Grievous and he's like, hello there. And he's General Kenobi.
Badass. Yeah, I can't debate with him, man.
Mr. QTube, first name Faf, $2 says, even an 80 IQ is higher than a Flerf.
Let's bet, right? Dude.
Connell Silverford,
hey,
$5.
Tell the debate me.
Says, not a typical flat earther. Wendell, you're every walking flat earth cliche ever. P.S. It will take billions of years to lose our atmosphere as it is. Yeah. I'm hoping Professor Phil Bell is going to take you through the maths of the atmosphere. Edward J. Peters for $2 says, ask the flat earther to explain the belt of Venus.
Oh man, no, I can't. I'm not doing that shit.
Fair enough.
I mean, look here, I'm not gonna make a fool out of myself with things that I don't debate topics that I don't know anything about. So I'm not going to do that shit. Enough. I'm not debating Van Allen's radiation belts and the asteroid belts and none of this other shit.
It's the Van Halen, isn't it? I'm kidding. Lord Luminous Pooh for $5 says, emergency NASA meeting on the moon base. The sun projector is broken. Do not read. Dude, I've told you before, those things are for internal chat. Shit. I'm going to have to delete this stream. Oh, fuck's sake.
Found you out, man.
Yeah, man. Skidmark McGee for $5. Every Flerf I've seen on your show has said how they're not a typical flat earther, but has the exact same talking points from their echo chambers. Oofed.
Yeah, you can say what you want, man. I'm not in any echo chamber.
To be fair to Wendell, he doesn't have a Papa Flerf as far as I can tell.
I think mine's based on standing model, brother. Hey, before I was a flat earther, I always had a problem with gravity. I always watched debates, Stanford University, MIT, where these people who are not flat or round earthers debate gravity. It's a subject that's always been interesting to me, and it's going to be an ongoing debate in the science community. And if your viewers can't understand that, they're the fucking idiots.
Look into Cavendish experiment, though, to prove the attractive force.
Right.
Pat in the chat, member for 7 months, says, Wendell, you seem like a nice enough chap. Now, please, for the love of God, make an actual working flat earth map and get back to us. Caucasian Sensation, member for 12 months, says, snakes, nothing should move without wings, legs, or fins. Yeah, they're fucking horrible, right? And last super chat, LB Things, Stuff and More for $2. Wendell, if you study plus experiment, you will understand. All the love.
If I understand what experiment?
He said, if you study and you experiment, then you will understand.
Right, that's what I'm doing.
And then he gave you a love heart.
I do this for fun, man.
And Tim Pryor, for $5, says, that's funny. He said he does not want to debate our things he knows nothing about, but wants to debate about the shape of the Earth. Yeah, same as one earlier. That's going to be it for tonight, guys. I've had a great time. Wendell, would you like to have any closing thoughts?
No, man. Like I said, it's been fun. It's always fun dealing with you. You make it interesting. I'm going to have my views. We're going to agree to disagree, but I do respect your intelligence, bro.
Thank you very much for coming on, Wendell. I'll arrange a debate between you and Professor Bell. We'll see when we can get that sorted.
And I'm gonna tell you what, man. If you up for it, man, let's debate that moon landing whenever you get a chance.
I'm happy to do that as well. Absolutely.
Yeah.
I'll be back tomorrow with another couple of debates, possibly, but definitely an episode of Debate Shorts. Friday will be a new episode of Flerfs Are Idiots, titled "The Dumbest Flat Earther Has Returned." It's about Riley. And then Obi-Wan for $50 just because.
Damn.
Dude, may the Force be with you. Wait, that's the wrong.
Fucking Obi-Wan is awesome, man.
Yeah, you are, Obi-Wan.
Yeah, Obi-Wan fucking awesome, man.
Thank you very much, guys. Thank you very much for the super chats. The support means the absolute world. You've no idea. The amount of memberships and stuff is insane. I'll see you tomorrow and Friday. And thanks for watching. And remember, stupidity is not a right.
Peace.
Fight the flat earth.
Take care.
Fight the flat. 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 Fight the flat.
Your baby dancing.
Fight the flat. Fight the flat. Fight the flat. Fight the flat. Fight the flat.
I'm an idiot.
I'm a stupid
Moron. Fucking ugly face. And a big butt. And my butt
smells, and I'd like to kiss my own butt.
I'm an idiot.
Good night, all. Love you lots.